Indian, and he's from Punur, and now he's a national postdoctoral fellow in NIT Calicut and research. And he was a research associate in Space Physics Laboratory VSSC Trivandrum and senior research fellow in Space Physics Laboratory VSSC Trivandrum and junior research fellow. He was an ISR also headquartered Bangalore in India. We are so happy to hear you are associated with this ISRO because the chief patron and member of this space club is a former director of ISRO, E.K. Kutty sir. And I invite all the personalities and all the dignitaries who join here, including the members of our webinar family. Once a person come to here and present something, he will become part of this UL webinars family, and we invite all of you. Jyoti Basu sir is there, Dr. Shivaraman sir is there, and I know Calicut CMA Anil Kumar sir is there. A lot of personalities are there. Then we have the plastic lady is there. That is our beloved and respected Lisa madam, Dr. Sujit sir, and I welcome all of you, Ravi Shankar Babu sir, all of you. Happily invite all of you to be part of this webinar, and I invite our chief guest and the presenter, Dr. Abhilash sir, to speak about the hot subject today. A warm welcome, sir.
Hello. Thank you, Sanju sir, for the introduction. Is it audible? Hello? Hello?
Yes, sir. Okay. It's okay, sir.
Yeah.
Yes, sir. It's audible.
Yeah. Thank you. Actually, in fact, I would like to thank UL Space Club for inviting me, especially Professor Ravi sir, who has invited me to take this session, and Professor Moshin and Dr. Kutty sir. First of all, I would like to thank all the members, and I'm little nervous because when the organizers talk about this seminar, Devamar sir told me mostly students will participate. But by seeing this participation, I could say that this is an eminent forum. Because I think students are very less. Means like all are well-known figures. I could see many like Sijin, many are there who are already well-known, eminent scientists in the field. So actually, I prepared the talk for a basic view, means with the fundamentals and all. Anyway, I will continue because today's topic given is. Can I share my screen?
Yes, sir.
Sir, just one interruption. We have here right now 54 participants, of which about 2 dozen, about maybe some 15, 16 maybe professionals or elders. The rest are students who are generally from 10th plus 2. Just for information, please.
Okay. Okay, sir. Thanks for the information. Yeah, today the topic which we have selected is climate crisis and sixth extinction. So basically, for the students, I will start with what is the fundamental difference between weather and climate. The weather is nothing but what we experience for the day, for the particular location, for the particular time and particular day, what we are experiencing for that day. And but climate is a long period average of this weather features, maybe of the means like more than 30 years of average weather is known as climate. So that means in essence, if you talk about weather and climate, it is nothing but weather refers to the day-to-day experience of the atmospheric condition, and climate refers to the climate is nothing but what we expect for that day. So our expectation is the climate, but our experience is the weather. So So then I would like to ask, there are general conception that most of the common people, they may still think that everything is created by the God, and human is changing our climate. So we have to ask this question ourselves: whether climate is changing due to human, or climate is changing not due to human. So in order to find the answer for this, we have to look at the entire history of the Earth. So we know that we have to go back little bit back to the history of the Earth, not the on the geological time scale. But I will not talk about the geological periods and all. But in essence, I will in brief, I will go through the Earth history, Earth climate history, not the Earth uh, geological history as such, but Earth climate history. So we can find that we all know that the Earth came into existence maybe 4.6 billion years back. And that time, if you look at the temperature of the Earth, we could see that the temperature might have been more than 100 degrees Celsius, maybe between 100 to 500 degrees Celsius. We don't have a correct proxy record of the temperature of the Earth when it was formed. So anyway, it might have been greater than 100 degrees Celsius, so that whatever water was on the Earth's surface or the atmosphere may be in the form of gas. So that after the formation of the Earth, it took some time to cool down below 100 degrees Celsius. Then around between 4.6 billion years and 3.8 billion years, Earth temperature came down to a state of around less than 100 degrees Celsius. So then what happened is that whatever water vapor present on the Earth's atmosphere might have been condensed and formed maybe the first ocean. So that is the time when water in the liquid form formed on the Earth's surface, and then after that, maybe around 3.8 billion years back, we could see a single life form, the prokaryotes, without nucleus. They form. It is a kind of, but when it formed, it is a kind of means that they didn't have the ability to ability of photosynthesis on its own. But then later they depend on many other forms of energy. I am not going into the details of that. But later they developed like cyanobacteria and all. They developed a capability of photosynthesis by consuming carbon dioxide from the atmosphere and liberating oxygen. So that means between 3.8 billion years and around 2 billion years, almost like 2 billion years. So the Earth biota is mostly controlled by this single cell, small single cell bacteria or the prokaryotes. They develop the ability themselves to convert carbon dioxide in the presence of sunlight, and they produce oxygen as a byproduct and carbohydrates which we need for energy. So then maybe around 2 billion years, if you look at this period before 2 billion years, the Earth history, we can see that the temperature, regarding temperature, we don't have much precious proxy records about the temperature pattern of the Earth. But still, we can say that there are a lot of fluctuation happened in between, and also there are a lot of geological activities in terms of tectonics, plate tectonics, and all happened during those periods. But after between this 3.8 billion years and 2 billion years, if you look at the initial atmospheric composition, we can find that oxygen was nearly absent. Concentration was almost like zero when Earth formed. Then after the prokaryotes, the cyanobacteria, they developed the ability to produce oxygen as a byproduct of the photosynthesis. So then only the oxygen accumulated first in the ocean. We all know that the first life formed in the ocean, in the water, and then they developed this photosynthesis capability, and they liberated oxygen as a byproduct. And oxygen amount in the ocean might have been saturated first, and that leads to the oxidization of lot of minerals, and that is what we are getting a lot of mineral deposits nowadays from the ocean floors and all. And then subsequently the atmospheric oxygen content slightly build up. So that means if now we consider the composition of the atmosphere, it is like dominated by nitrogen of around 78%, followed by oxygen of 21%, less than 1% of the means total volume contains only these minor gases. So that means this composition means this stable composition of the Earth atmosphere came something between 2 billion years and 1.5 billion years. After that, only around 1.5, 1.8 billion years back, these prokaryotes become eukaryotes, and they become like cells with nucleus. And then, and even after that, also from 1.5 billion years to almost like 0.5 billion years, like 500 million years. All these geological periods it is divided as eons, eras, epochs, periods, and all. But collectively, this blank out this period is collectively known as Precambrian period. And just around the Cambrian time, the entire Earth witnessed a sudden explosion of the biota. That means our biodiversity started actually maybe 500 million years back. That means 0.5 billion years. So that means around 400 crores of years, like 4 billions of years, Earth was only composed of small, tiny, single cell organisms. And then after that, around the Precambrian period, we could see that Earth witnessed a sudden explosions, that is sudden transformation of the biota. That means biodiversity actually started from that point onwards, and this single cell organism evolved into many bigger forms of organisms. So this before this 500 million years period is collectively known as Precambrian period, and around the 535 billion years, that is the Cambrian period, starting of the Cambrian period, that is known as actually this sudden evolution of this biological species is termed as Cambrian explosion. After that, this as far as biodiversity is concerned, we have to zoom down to just 500 million years of Earth history. So this is where this introduction. And if we look at this 500 million years of Earth history, we can find that first this single cell converted into bigger forms like invertebrates. Then Cambrian explosion of the life begins. Then first fish evolved around 500. That is known as era of fish, 500 million years back. And then first land plants and animal evolved. Then what happened is that between 400 and 300 million years back, the life forms which has the ability to live both in water and land, known as amphibians, they evolved. And from amphibians, they started evolved over the land, and they eventually evolved into reptiles. Then around 200 million years back, mammals, and then between 200 and 100 million years, first flowering plants and insects, they co-evolved. That is, from that point onwards, we can see that there is the biggest association between animals and plants, especially flowering plants and animals. Not only the bigger animals, the small insects, because they co-evolved, because flowers need pollination, so that is being carried by these insects. So they co-evolved actually. And after that, between 100 million years and maybe less than 100 million years, our ancestors like primates and different forms of hominids evolved. So if you consider the history of modern humans like Homo sapiens, we have only a history of less than 2 lakhs of years. And if you look at the total geological history or geological age of the Earth, we can say that we lived modern. Before that also, there are many kind of hominids lived on the Earth, like Homo erectus, Homo neanderthals, Homo many other species. So now we are the modern humans like Homo sapiens. We have a history of less than 2 lakhs of years. If we consider total history of the Earth, we lived only less than 0.01% of the total age of the Earth. So this is where the brief history of the evolution of the life and interaction with the atmosphere and climate. So then when we come down to this 500 million years of Earth history, if these are the latest 550 million years of temperature history of the Earth, like we could from many kind of proxy data we can estimate this temperature. So we can find that Earth never remained on a stable climate. It was evolving all the time. So that means that green line is the baseline if you consider, and above that is considered as the anomaly. Anomaly is nothing but the deviation from the normal climate. So that means sometimes it was above normal, like hotter climate. Sometimes it came to colder climate. So that means it is a seesaw oscillation between colder and hotter climates. So this is what the Earth has witnessed maybe in the last 550 millions of years. And in this history, because why this 500 million years is very much important is that in this period only Earth could see lot of other bigger life forms. So that means if you want to talk about the extinction event, we have to talk about only the last 500 million years. Because before that, there were only small single cell organisms present on the Earth. So then, if you consider the first mass extinction event, maybe in the Ordovician period, then followed by Dinovian and Permian, then Triassic, and latest in the KT period, like Cretaceous means KT thermal maximum period. Also, we have witnessed a great mass extinction event. And if you look at this extinction event happened on the Earth, so we could find out some linkage of climate change. That means suddenly the climate is changing, like is moving from colder to hotter, hotter to colder climate. So that period witnessed lot of most of the living organisms go extinct due to this changes in climate. So that means there is geologically there is a link of climate change to the extinction events. So this is what the beauty of studying the history of the Earth, because history generally we study because, mainly because we don't want to repeat the same mistake what had happened in the previous history, so that we will learn from the history. So that means we have the history of great extinction event on the Earth, maybe in the last 550 million years, that is linked to the changes in climate. That is what I want to say here. So then now, if you zoom down to just 4 lakhs of years of the Earth temperature and carbon dioxide history, because we are moving down closely to maybe less than 1 million years of history, is that we have proxy records of ice cores and Antarctic ice cores and or maybe earlier up to maybe the crisp records is available up to 8 lakhs of years back. But if you just look at this Earth climate history in terms of temperature and carbon dioxide for the last 4 lakhs of years, we could see that Earth has gone through some kind of glacial oscillation between glacial interglacial period. That means Earth has gone from one interglacial period to the next interglacial period in about almost like 75,000 to 1 lakh years. So that is the, and again it will go like that. Last glaciation lasted stopped around 20,000 years back. Now we are at a interglacial period. So that means if you consider the cyclic features of this changing temperature history of the Earth, we can see that Earth is going through a cyclic changes between glacial and interglacial cycles. This is not anthropogenic. This is a natural climate variable. And before that also, a lot of changes had happened on the Earth history. So that I briefly discussed. That is also not due to human. So what is here important is that if you consider the changes happened in the previous, maybe 200 years back, we can say that the changes happened over a year of, maybe in the latest glacial interglacial cycle is happening over a period of around 75 to 1 lakh of years. And before that, even millions of scale, year scale, the changes have happened. But now, if you look at the carbon dioxide concentration and temperature concentration, here we can see that I have given a line, like a violet line, as a threshold line. That means the carbon dioxide concentration of the Earth atmosphere, maybe in the last 1 million years, doesn't overshooted above 300 ppm. So maybe by the time Earth formed around 4.6 billion years, like that time, that is known as giant means phase and paradox. Like that means temperature was higher and the solar input was less. So in order to compensate for that, solar input carbon dioxide concentration might have been very much higher than during maybe 4.6 billion years. That is also still the but if you consider the last 1 million years of the atmosphere history from the reliable proxy records, never shooted up above 300 parts per million volume. So now if you look at over the last 150 years, we can find that now the carbon dioxide concentration on the Earth atmosphere is almost around 414 parts per million volume. So by volume. So that means it compared to the baseline or the benchmark concentration of 300 ppm is overshooted of around 140 ppm compared to the natural process. So that means this overshooting of 114 ppm excess carbon dioxide in the atmosphere is mainly contributed by the human activities in terms of fossil fuel emission. Mostly, maybe 80% of the contribution is coming from the fossil fuel. Another 20% is also contributed from other anthropogenic activities. So this is the difference. So whatever had happened on the Earth history, maybe over the geological time scale or over the 1 million time scale, we can say that it is happening over a period of lakhs of years. But now what is happening, whatever we had seen in the Earth history, maybe before human means human era, we can see that now in 150 years, we can see that it is happening which had never happened on the Earth's surface, at least for last 1 million years. So this is what the whatever happened in the earlier period, it is happened over a longer period of time. Now it is happening on a just year time scale. So that is the main difference between the natural changes and the anthropogenic changes. So why this time scale is important is that if you look at, I am briefly telling that also here because we have to consider the ecosystem point of view and the evolution point of view. All these factors we have to consider, because if you look at the evolution history, means life evolution history, it has also got a definite link with the climate history, because the evolution, the Precambrian explosion happened when due to photosynthesis, oxygen is came to a saturation, means a stable limit of around 21% in the atmosphere. After that only maybe the Cambrian explosion in terms of biosphere happened. So that means it has got all this, and also after that also each extinction event has got a connection link with the climate changes. And if you look at the evolution history, each evolution history has got a definite link with the changes happened in the climate. So that means it is a kind of evolution, is a kind of existence for response. That means if whatever species lived on those periods have got a ability to evolve with the changing climate, so that they will evolve to another species, or their genes will evolve into another. The gene also will go for a lot of mutations and all. So that means that is also linked to carbon dioxide. The difference is that if life forms or the bigger or smaller life forms, they have got a longer response time, like longer period of time to respond to this evolving climate changes. So they will naturally evolve into, they will try to exist natural choice. So that means evolution, the natural selection. But if you look at the last 150 years of changes happen in terms of climate, in terms of the climate history of the earth, we can find that this is happening over a short period. So that lot of small species and small life form, they even don't get the time to respond to these changes, and they may instead of evolving, they may go extinct. So that is the difference between. So and we had a good history of extinction happened on the earth in the previous time scales, and that whole extinction had a link with the climate change. So that is what the history is also important. And then if you look at the natural, here we have to distinguish between the natural causes of the climate change. Just briefly, we have to look at the natural causes of climate change and the anthropogenic. Natural cause, we know that we are getting the primary energy source from the sun. So whatever changes happening on the sun will naturally affect our earth also. So that means sun is emitting almost like 30%. That means when earth was formed, now sun is that time sun was emitting almost like 70% of the energy what sun is emitting now. So that means that change is happening on the sun, but it is happening on the billions of time scale. But one human generation will not feel that. So that means it is beyond our realizations. Then another bigger natural changes happening is with respect to what the climate changes is due to the changes in the earth itself, like orbital changes in the earth itself, like eccentricity of the orbit of the earth changes over a time period of lakhs of years, and then precision of the precision of the earth changes over a year of 25 to 30,000 years, and the obliquity of the that means now it is around 23.5 degree. It can move between 22.5 and 24.5. So that changes is a cyclic process that is taking around 40 to 50,000 years. So this all orbital changes associated with the Earth orbit is collectively known as Milankovitch cycles. Maybe this 1 lakh, maybe from 50,000 to 1 lakh year time scale of changes happening on the Earth is mostly linked to this bit. Maybe the link to the Milankovitch cycle. So that is natural variability that we have already seen in previous image. There is a glacial interglacial cycle happening over a period of around 75 to 1 lakh of years. So that is mainly linked to this Milankovitch cycle. And then volcanic activity that is also not produced by the human. Volcanic activity, that the previous extinction event and the previous changes in the temperature of the Earth climate is mainly that drastic sudden changes on the earth climate was mainly contributed by the sudden volcanic activity. So now also volcanism is reduced nowadays, but earlier it was very common. During that time, climate of the earth also might have been changed by changing the composition of the earth by injecting more and more greenhouse gas to the atmosphere. So the volcanism is also got a direct link to the changes in the atmosphere, which in turn changes the temperature of the earth.
Excuse me,
sir.
Excuse me, sir. Excuse me,
Yeah.
sir. Just enlarge your slide, sir. It's a little bit small, sir.
Actually, I made it like this because PowerPoint is not working in my.
Sir, okay, sir. Okay, sir. Thank you, sir.
Okay, not possible.
Okay, sir. Thank you, sir. Thank you, sir.
Yeah, this is volcanic activity. Regarding volcanic activity, that is also very natural factors. And another main thing is the greenhouse effect. That also I will come because everybody is nowadays believe that greenhouse is produced by man activity, means anthropogenic activity. But in reality, in the natural sense, also greenhouse gas is a blessing to our earth. So that I will discuss. Then tectonics and ocean currents also one by one. If you look at the changes in the seasonal, what is the reason for the seasons? 4 seasons is mainly because of the inclination of the earth and the revolution of the earth. So both together contributes to 4 seasons. If there is no inclination, we are having only 1 season all the day. It is go around the sun. So that is the difference. And if you look at what is the unique feature of Earth is that after Mercury, Venus, Earth, only Earth has got life and water. Uh, because I don't know whether many other planets or exoplanets have water on the Earth, but water on it. But if you consider at least the solar system, Earth is the only planet which has maybe Mars or something. There are evidence of water in that, but now the uniqueness of Earth is nothing but it is situated at an optimum distance between from the sun. So if you, that means Earth is a optimum distance of around 150 million kilometers from the sun. So that is the main uniqueness. And then if you look at and if you replace if you, then this is not the distance between sun and Earth is the not the only factor which determines temperature of the Earth. And if you replace Earth with Mars, can we expect the same temperature? No. Why? Because not only the definite that optimum mass of the Earth, optimum distance, mass is also determined. The gravity is determined by the mass, and then this gravity is actually holding the atmosphere around the planet. So that means all this together making the uniqueness. So and in that distance between the Earth and Sun, along with the atmosphere of the Earth, is the main reason why we have this optimum temperature on the Earth. If we consider there is no atmosphere on the Earth, there is no greenhouse gas on the Earth, so Earth temperature would have been something like minus 16 degrees Celsius. So that means in the presence of the atmosphere, which is having some kind of greenhouse gas, optimum concentration. That is when only now it is only less than 1% of the total concentration. If you look at other planets, maybe 90% of the atmosphere may be composed of carbon dioxide, so that the temperature of that planet might have been more than the Earth. So that means it is not only the distance, the uniqueness is mainly because of the optimum concentration of greenhouse gas on the Earth atmosphere. So that means it is contributing like sun is emitting energy in short wavelength, that means shorter wavelength, and it is almost our atmosphere is almost like transparent to this shorter wavelength radiation. And if you look at the spectra, Earth receives this energy in shorter wavelength, and then based on the Earth temperature, it re-emits energy in the longer wavelength region, which peaks around 10 micrometer. And if you sun's energy spectra, it peaks around 0.5 micrometer. So that means while emitting the long wave radiation, so there is a balance between incoming radiation and outgoing radiation. So this balance is mainly because of if whatever is emitted from the Earth, if it is easily escaping to the space, then Earth will not warm. So that means a portion of this energy which is being emitted by the Earth has to be trapped or absorbed by the atmosphere, then emit back to the Earth. So that is because of the presence of greenhouse gas. That in essence, a greenhouse gas or the atmosphere acts like a blanket to the Earth. So that means if you put a blanket, that means the temperature will not reduce. Like if you go into polar region or the colder region, you normally put blanket to maintain your body temperature. Like that, atmosphere acts like a blanket to the Earth. So that means if this blanket, if you put two blankets instead of one blanket, you will feel the hotness. So that is this double blanketing effect. If it is coming, that is because one blanket is natural. So double blanketing is produced mainly because of the anthropogenic activities by the emission of more and more greenhouse gas to the atmosphere. So this is what the difference between natural greenhouse gas effect and the anthropogenic greenhouse gas effect. All this I think I have discussed. These are the natural factors which is causing the climate change, and uh, and another main factor is the plate tectonics. So if you look at this was also very much important in terms of extinction also. Climate of a particular place is depending on and at which latitude or longitude that place is. So that means if you look at 225 million years of million years back, there was only one super continent like Pangea, and after that, around between 225 and 150 million years, it split into Eurasia and Gondwana. So Indian plate was part of Gondwana, and then Gondwana again split up into Africa, South Africa, South America, India, Australia, and Antarctica. Then around 100 million years back. So after that, Indian plates started moving towards north, and along with the Indian plate, initially there was a small part in the south, which is now, if you look at the present orientation of the continent with respect to ocean, we have 7 continents and 5 oceans. So this structure is stabilized maybe in between 100 million years and 50 million years. So this is the present climate age. So if you look at the age of the present climate age, we can say that present climate has an age of less than 50 million years. Because this orientation of the continent with respect to ocean is making more of this climate structure. Because as we know that most of the energy from the sun, solar, based on the solar zenith angle and all, we can say that most of the energy from the sun is concentrated between Tropic of Cancer and Tropic of Capricorn, between 23.5 degree north and 23.5 degree south. This region on the earth is commonly known as tropics. So there most of the sun's energy is being gained. And if you look at the polar region, there most of the energy, sun's energies will not reach there. So that based on the radiation law, we can say that polar region constantly lose energy, tropical region constantly gains energy. So this excess energy, if it's every time if tropic is getting this energy, it will warm up. So it is not happening, and polar region is not cooling down. So that means there is a transport of energy from polar, so the tropical region to the polar region. That is mainly through atmosphere and ocean. So that means this orientation of Earth, the present orientation of the Earth and present climate history is maybe having a age of less than 50 million years. And here, if you look at Indian climate itself, there's a very big thing happened. Means our Indian climate is mostly we refer Indian climate to monsoon, Indian monsoon. This Indian monsoon is mainly because of the presence of the Great Himalaya and the Tibet north to it, and the orientation of our landmass with respect to Indian Ocean. So this type of orientation of the continent with respect to ocean is the main reason for the formation of Indian monsoon. If you look at all other region, you won't find any kind of monsoon type of circulation or wind pattern or other region. That is because they don't have other region, don't have Himalaya, don't have Tibet, don't have Indian Ocean orientation like a closed ocean basin. So all this orientation might have been the reason. If you look at the monsoon history, age of monsoon may be less than 50 million years, because when Indian plate collided with the Eurasian plate, that is the that led to the formation of Himalayas. If you consider the age of Himalayas with respect to age of Western Ghats, we can say that Western Ghats is much older than Himalaya. So maybe Western Ghats formed maybe when Indian plate was with Gondwana. So that is another geological features I'm not discussing. I just want to say that this type of all this together, like not only the sun, the whatever happened on the earth in terms of geological activity, also responsible for the stable climate state of our earth. So this is what had happened in brief on the earth's surface. And now, if you coming down to the last 150 years of atmospheric climate history, we can find that human is contributing much. Human is contributing which is mainly driven by the explosive population growth. Because if you look at 1950s, the population was something less than 2 billion, the world population. Now we are reaching almost like 8 billion in around 70 years. So that means we have to satisfy the needs and maybe the essentialities of all this population, so that we have to exploit more and more resource from the earth. And another, due to that, we are emitting more pollutions, and we are cutting down the forest, and we are making lot of plastic, not only on the land and on the atmosphere. So this is what is happening nowadays. Maybe if you look at the last 50, 60 years, it is mainly because of the explosive population growth that leads to all these changes. And if you look at the global average carbon budget, it is not the earlier budget. If you look at it now, earlier it is like whatever is emitted from the biological activity to the atmosphere, it is compensated equally by the consumption of photosynthesis, which is happening on the land and ocean. So that means it is more or less balance was correct. It remained almost like in a balanced form, it was neither sink or source. But now, if you look at the total emission from the anthropogenic activities as well as from the biological activities, if you can say that roughly it comes around 10 gigaton carbon. Not the gigaton carbon dioxide, it can be converted to the carbon dioxide equivalent also, but it is almost like 10 gigaton carbon. Out of this 10 gigaton carbon, 5 gigaton, 4.5 to 5 gigaton is being absorbed by both by the forest and the ocean. Because ocean also, there are a lot of photosynthesis happening on the ocean also. That is also considered as the sink. Now it is considered as the sink. That can also change. Maybe ocean can also sometime in the future may become a source also. So that means, in essence, out of the 10 gigaton of carbon which is being emitted to the atmosphere, only half of it is being absorbed naturally, and out of this half of this carbon, almost like 4 gigaton carbon is being emitted only in the atmosphere every year. This is the emission every year. So that is why in the Hawaii Island, there was a carbon observatory that started around 1970s. So if you can see that the concentration of carbon dioxide is going every day, every year, almost like 2.5 to 2 to 2.5 ppm per year. On that rate it is increasing. So next year also, maybe now it is 412, 414. Next year maybe 415 or 16, because that may reduce, because now due to lockdown and a lot of anthropogenic activities altered. And another here is the another view of this why this climate change is important in terms of extinction is that in previous history, maybe around 60 million years back, that is known as PTM, Paleocene thermal maxima, the Earth climate was around 5 to 10 degrees warmer than the present day climate. So that time, what had happened is that at that time was the 80 period where dinosaurs and all extinct from the Earth surface. So that there are many theories like impact of asteroid in the Mexican region might have been the reason for the entire collapse of the biodiversity on the Earth. But it is, if you consider the Earth climate history, that extinction has got a good link to the climate changes, because the Earth temperature was around 5 to 10 degrees warmer during those periods. That means Earth was already on a disturbed state in terms of climate change or in terms of temperature, and maybe linked to the volcanic activity liberated a lot of carbon dioxide to the atmosphere. So that time an asteroid impact might have been accelerated this extinction event. So that means it is not just about the Mexican asteroid impact, it has got some link with climate change also in the around the last extinction event which has happened between 60 to 65 million years back. So that now we are here something here. Our temperature of the Earth is something like 1.2 to 1.5 degrees Celsius warmer than the base period. So that means our climate is warming, that is global warming, and with some computer simulations and computer models and all, we can project, if we continue to emit the carbon dioxide at a rate of 4.5 gigaton carbon per year, so we may end up with like by 2100 temperature of the Earth will be 4 to 5 degree warmer, and by 200 it will be something like 5 to 10 degree warmer than the present climate. So that means this, if it is happening like this, we will reach a Parios in thermal maximum type of situation. We had witnessed the latest extinction event on the earth. So we are, in essence, we are approaching towards that stage in terms of temperature of the earth. So that can lead to another extinction event on the earth. But it is not just connected to the temperature change alone. A lot of human activity also is being linked to this degradation. So that is what studying. This is a kind of proxy or analog situation. This is something like 65 million years back. And here now, this is what in this stage we can say that there is a organization known as IUC, an International Union for Conservation and Nature. They every year they identify few means few species, the number of species in some selected among some selected species. They found that like a 40% of the amphibians community is under the verge of extinction, and like that mammals 25%. Altogether, if you consider the present state of extinction threat, like 25 to 30% of the total species is being under the verge of extinction. So that every year, both the terrestrial species and the marine species, freshwater species, marine species, the number concentration is being increasing every year. They found out that, from that survey. So this is also means pointing towards another, maybe another whether the Earth is going to witness another major mass extinction maybe in the near future. So here is what another study by MIT group. They are also proposing that if we are emitting like this, and our temperature will is like 5 to 10 degrees warmer by the end of 2200, and that time we will reach a similar situation like PETM thermal maximum event. So that may also, I don't know whether it is exactly driven by asteroid impact. If it has got some kind of link to the climate change, you can say that this may go towards that state situation, maybe in the near future. So the main difference is that earlier what had happened is over a time scale of lakhs of years. Now it is happening over a time scale of just a few years. That is the difference. So this rapid intensification is the main difference. We in other terms, in terms of climate change, if you look at the climate changes happening on the earth, we can see that all our climate is like extreme events are being increased, like floods, droughts. Flood is also increasing, drought is also increasing. That means that every one location is witnessing flood at the same time drought. So intense thunder clouds, wild weather, cyclones. In terms of cyclonic activity in the Arabian Sea, we can in the last five years we could see many cyclones coming towards Arabian Sea. That is also there, and melting of ice, forest fires, sea level.
Hello.
Yes,
Sir, is it possible to press F11 key? Then there is a suggestion to get the full screen. F11.
No. Actually, I opened this in Explorer. That is also because I am not using my tablet, my laptop. I was because I converted.
Just convert here. So,
Others can pin it, then it will be full screen.
Can I continue? Means.
No, so those who are using laptop can press the pin it button, then it will show full screen.
Okay.
Kindly repeat. I'm using laptop, but I would like to know which button to be pressed.
If you move to the image of there, then you can see a pin button, a pin. Then you just pin it. Click on the pin.
Okay. Yeah. Thank you. I'm getting it.
Okay.
Sir, how much more time is there?
schedule, sir?
Sir, it's 4 o'clock, sir. No problem, sir. We can take some more time, sir. No problem.
Okay, maybe I will complete in another
No
5
problem.
minutes.
No problem,
Okay.
sir. No problem. We
Okay.
are ready. Only,
Okay.
only suggestion is just to reduce some little bit of speed, sir. Okay, sir. Okay, sir.
Sir, it's okay. Your Masar is also there, so no problem. So, this is what is happening in terms of changes on the land, and if you look at the changes happening on the ocean, that is also very high because we normally neglect ocean part from the though ocean is very much important in terms of climate system, but we all normally neglect ocean because water happening in the ocean is also very much important. Sea level rise, sea surface temperature is increasing, ocean heat content is increasing, ocean acidification, ocean is getting more and more acidified due to the extra carbon dioxide is being absorbed by the ocean, both due to physical and biological activities, and then the melting of sea ice. And another major threat is hypoxic area, especially Arabian Sea and Bay of Bengal is witnessing kind of hypoxic region, the Arabian Sea, where there is a lesser concentration of oxygen in the water column. So that type of water column will not means will not help in sustaining the species over there. And then hurricanes, typhoons, everything, cyclones are being increased, and then storms are due to the storms are this. If you look at the entire Earth climate system, we can say that it is like a human system. There are different parts of the system like biosphere, cryosphere, atmosphere, hydrosphere, lithosphere, and all. Which all together is working in a coherent or synchronized manner, so that the climate system is in a almost like a stable stage. So that now, if you look at the biosphere, if human is considered as a part of biosphere, maybe before around 50 years back, 1880s back. But now, if you consider human, and another thing is the ecosystem. Ecosystem, we don't know the meaning of ecosystem itself now because all are thinking that ecosystem is related to the biotic components, but ecosystem is nothing but the coherent or synchronized means transformation or the evolution between or the interaction between both biota and the abiotic components like soils, water, air, and mineral. Everything is asked to interact with the biotic components. And only that is making the ecosystem. But in terms of biodiversity and ecosystem, our link to this whole ecosystem is mainly because of the, if you look at the energy pyramid, we can see that we are very much linked to these primary energy producers like plants. And then if you consider last 160 years, we can say that human can be considered as another sphere. Like earlier, it was part of biosphere. Now this is a period of Holocene, but now another period has been defined like Anthropocene or Anthroposphere. So where human has become a largest geological scale sourcing, so that we can alter the entire functioning of the earth and also its climate. That's what humans have become. Earlier, if you consider what of this climate change had happened mostly due to geological changes, or the changes happen external to the earth, not due to human. Nowadays, the changes is mainly driven by human activities. So that is why Holocene part of this year, maybe after 1950, is being considered as Anthropocene, and we are being the Manushya Mandalam, Anthroposphere, which is outside the biosphere. So that means if you look at the last 150 years, we can see that it's already I mentioned the population increased from 2 billion to 8 billion from 1950s. As with GDP, foreign direct investment, primary energy use, urban population, everything is being used. There are two indicators of this change, like a socio-economic trend and a persistent trend. So this persistent trend and the increase in carbon dioxide concentration after 1950, this is very much linked to the socio-economic trend like population, GDP, and all. So that means human is the main culprit for this means rapid changes happening in the Earth system components like carbon dioxide, nitrous oxide, methane, ocean acidification. So this is being witnessed. Rapid intensification is witnessed or witnessed maybe after 1950s onwards. So this is the great acceleration period as far as Anthropocene is concerned. And if you look at the role of ecosystem, the biggest two type of ecosystem is the ocean and the forest. If you consider ocean, ocean is the we know that 70% of the total land surface is ocean and 30 is means air surface is ocean and 30 is the land. You will just imagine 30 ocean and 70 land. The ocean might have been filled up with man's activities. That means the if you look at the specific heat capacity of water, it is almost like 4 times that of atmosphere. So that and along with the total mass of the water, we can say that 90% of the heat liberated to the atmosphere is being absorbed by the ocean. Only less than 7% is absorbed by other land and atmospheric water. So in terms of absorption of heat, ocean is playing a bigger role. And in terms of absorption of carbon dioxide, the ocean is also taking up the carbon dioxide through physical pump and biological pump. So that is also almost like it's 25-30% of the carbon is being absorbed. And not only that, in terms of oxygen, the total oxygen we are inhaling is out of the total oxygen, more than 50% is produced from the photosynthetic activity happening in the ocean. So this way, ocean is making a bigger role in modulating and maintaining this Earth's climate system. So another is the main ecosystem part is forest and wetlands. I am not going to the and another one more thing I am concluding with here. Another concept introduced is the Earth overshoot day. If you look at the 1960 or 1970s, the Earth overshoot day is nothing but if you exceed the total biocapacity of the Earth for a particular year, and if we divide it with our ecological footprint. Ecological footprint means the utilization, resource exploitation of due to man activities. We can say that in 1960s we are just utilizing only 74% of the available world biocapacity. That is per year biocapacity. Only we are utilizing only 74%. Now, if you look at 2017, we are over exploiting, overusing, we are overstepping. Like we are out of 100%, not even 100%, 170% of the bioplastic. I mean, that means whatever biologically produced for next year is also being consumed this year. So that means every year we are overstepping. So that is the concept of Earth overshoot day. So that means here I want to emphasize a word. Quote by Gandhi, the Earth has given us a lot of natural resource for our needs, not for our greeds. So that means if you are consuming only up to the per year biocapacity, there is no problem. Otherwise, we have to have two Earth for satisfying our needs. So this is what another ecosystem point of view. Here I am because we are most of the participants are students. We can see that there are a lot of waves of innovation through technology. Only we can sustain further because we can see that there are a lot of waves of innovation in terms of water power, maybe after 1970s, and then second wave of steam power, then electrification, and fourth is space age. 1960s onwards, we have witnessed a lot of development in the space technologies, and the last biggest innovation was the wave was the digital wave, like maybe 90s and 20s. And now we have to look for another wave of innovation that is nothing but sustainable innovation by which only we can sustain further. Or like Mark Papa has said, this entire Earth is not inherited from our ancestors. No, it is actually a loan from our future generation. So this is where I am stopping. We are the first generation to feel the effect of climate change, and the last generation we can do something about it. So it is that extinction event is not a joke, but it is a reality. But we can sustain through many our changes in our human activities, we can sustain it further. So that means Earth has got a healing capacity. That is very much important. Earth will not die. Every day say Earth has got a lot of dynamism. Earth never stayed in a similar stage for longer period. So Earth is constantly changing. So it will change. Even without human also it will change. So Earth will sustain unless and until sun's energy stops, Earth will be there. So that means only maybe human or other species may go extinct. And that may lead to evolution of another type of species. So that is the evolution history says. So that means we can also sustain this planet for another next future generation for longer period of time. That is what we have to do at this point of time. Thank you.
Well, thank you, Abhilash sir, your wonderful talk, for your wonderful talk. And you made it an optimistic view that we can survive here, the Earth will survive here. Only thing is that we have to adapt with that. And next is our panel, the turn of our panelists. I invite Dr. Yorma to speak or make his comment on this. After that, after the panel discussion, we'll invite the student to ask their questions. Welcome, Yorma sir.
Okay, Dr. Abhilash, it was a very interesting discussion, and have you spoke as an expert in the area, and it's an important discussion that we need to impart to our future generation. The students who are growing up should know that while we are doing the run or the rat race for our establishment, the career, then we tend to overconsume, and when we establish in life, we tend to overconsume more. So, what is that going to do to our ecosystem and to our surroundings? And like you said towards the end of the discussion, Earth takes 1.7 years to regenerate what we use up in about a year time. So that's also very, very important thing to know. So global warming is a reality that we know, but if you look into the whole picture, the global warming may be there in different time periods, but we are actually contributing to it by burning fossil fuel and contributing to it, so that we are contributing to the change in the system to make it faster. That's what I gather from your talk. I think it's one of the most important topic of discussion for in such a forum. That's my opinion. I have a couple of questions, but I would let the other panelists discuss about it, and I will take my turn while audiences are asking questions. Back to you, Shajil sir.
Okay, thank you, Raghuva sir. He's also an expert in Earth atmosphere, and basically he's from physics, but I think he's most interested in life and biology. And we wait for his next turn again. And I invite Dr. Mohanjit to make his own comments and contribution to the talk of our Dr. Abhilash sir.
Abhilash, sir, it was a wonderful talk. You have covered the entire spectrum of the climate change scenario, from the starting of the evolution of Earth to the present situation of the Earth atmosphere system. And it is a well, what you can say, it is a need of the hour of
Mohanjit sir,
this
please switch
topic.
on your camera also. The people want to see you, sir.
Okay.
Sir, okay, sir, proceed, sir. Mohsin sir, okay, it's okay, sir. You continue. Mohsin sir, we are seeing you.
Yeah. Hello?
Okay, okay, sir, continue.
You can continue, Mohsen. You can continue.
Okay. My
The
video is on. I don't think. Okay. I'm not seeing. Okay. Whatever it is.
Video is on.
Okay. So, this topic is it's currently a very hot topic because it is affecting all of the Earth system. Not only the humans, but also all the animals in the Earth. So we need to have a plan or whatever it is, a criteria to sustain or adapt this climate change. So one may think that currently the Earth temperature has been raised by, atmospheric temperature has been raised by around 1 degree. One may think that what will happen is if it changed by 1 degree. By what we can see that even though it has raised by 1 degree, it is happening a lot of changes in the Earth atmosphere, like what we have seen, that floods after all those things. So we need to adapt this climate change. Okay. So this is my opinion regarding this. Maybe we can discuss after that.
Okay, thank you, Mohsin sir, for your valuable contribution. ഇവിടെ കുറച്ച് നേരത്തെ നമ്മുടെ ശോഭൻ സാർ ഇവിടെ ഇരിക്കുന്നുണ്ട്. സാറ് നേരത്തെ സൂചിപ്പിച്ചിട്ടുണ്ട് നമ്മളോട് പക്കാ ഇംഗ്ലീഷ് ആവരുത് എന്നുള്ളത് കഴിഞ്ഞ ഇതിനകത്ത് തന്നെ സൂചിപ്പിച്ചിട്ടുണ്ട്. അപ്പോ ഏതായാലും നമുക്ക് അതിന്റെ രണ്ട് മാർഗങ്ങൾ നമുക്ക് ഉപയോഗിക്കാവുന്നതാണ്. തീർച്ചയായിട്ടും നമ്മള് രവികുർമ്മ സാറിലേക്ക് തന്നെ വരുന്നു. സാറിന് എന്തോ കുറച്ച് കാര്യങ്ങൾ കൂടി ചേർക്കാനുണ്ട്, ചോദ്യങ്ങളുണ്ട് എന്ന് പറഞ്ഞിട്ടുണ്ടായിരുന്നു.
നമ്മുടെ കമന്റ് ബോക്സിൽ പോസ്റ്റ് ചെയ്തിട്ടുണ്ട്. എല്ലാവർക്കും അത് ഫോളോ ചെയ്ത് ചെയ്യാൻ പറ്റുന്നതാണ്.
ഓക്കെ, രവികുർമ്മ സാർ.
So, Abhilash sir, you mentioned that ocean is taking 93% of the water. Faster than the atmosphere?
What sir? I didn't get.
Ocean is taking 93% of the warming, right?
Yes.
So does that mean ocean is warming slightly faster than the atmosphere, or much faster than the atmosphere? Any information like that can be available?
Sir, what I mean to say is that considering the specific heat capacity of water and air, it is like 4 times more than air. But if you add up the total mass, you can say that that much amount of energy means heat is being absorbed by the ocean as compared to the atmosphere.
Yes. That is correct. Yes.
Yeah.
Another So the increase in the temperature, the increase in energy is actually going into the ocean. And,
Yes.
so does it create more evaporation of the water? Because it can also go into the latency of liquid to vapor transformation, and then does it contribute to the larger weather anomaly that we see? Means stronger rain, lot of rain in short time. That kind of phenomena can contribute to that. I don't know. It's just a doubt I'm just asking because we are seeing a lot of rain events, like too much rain in too short time. Maybe this global climate change could be contributing to that. So flash floods, and then later on, all the water is gone.
Hello.
I think something.
Abhilash sir, some connectivity problem is he left the meeting now. We will rejoin now.
Oh, okay.
Sir, regarding that, with your question, I have a comment. Sir, the water holding capacity of the atmosphere is a function of temperature. So once if the temperature increases, the water holding capacity of the atmosphere increases much higher. So once the atmospheric temperature increases, the evaporation increase, then that the evaporated water vapor will hold in the atmosphere. Once if it get that optimum conditions, that will fall back to the earth. That will be like a torrential rain. That causes the floods in the earth's surface. One thing is that in one place there will be a that flood, and other region there will be droughts. That is the main issue of the climate change or the global warming.
One more comment I would add to that is regarding the global circulation. So because of the temperature difference between the Earth equator and the poles are colder than the equator. ഭൂമധ്യരേഖയില് ചൂട് കൂടുതലും പിന്നെ polar region തണുപ്പുമാണ്. So that temperature difference makes the atmosphere and ocean like a heat engine, and it circulates the air and the ocean. And the temperature is moved from equator to the poles. So when there is global warming, the warming happens everywhere. The temperature gradient reduces, and it weakens the circulation, and it disturbs the climate. I think that is also there. I think Dr. Abhilash can comment on that too. And
Yes,
Dr. Mohan.
yes, sir. Yeah, I missed it because my connection was not some issues with net connection, so I missed some part. But I regarding Dioma sir's comment, you are true, sir. This circulation depends on the
Yeah, I think there is a more connection problem on Abhilash's side. So Dr. Musin can comment on that too.
Yes, sir. Definitely, that atmospheric circulation is mainly driven by the differential heatings of the Earth atmospheric system, because whatever we are seeing the general circulation of the Earth, that meridional circulation, that means from equator to pole, there is a circulation like whatever that Harley, parallel, and polar cells. That circulation that is mainly driven by the that thermal gradient. That means the more heat is there in the equator and lesser heat in the polar region. So that is mainly driving the circulation of the atmosphere. So once that gradient reduces, definitely the circulation patterns or circulation intensity will change. That again will cause the climate change impact. That actually that positively feedback the climatic that change.
Yes, actually, students who are listening to this circulation aspect. So this is like you might remember the stories that somebody wrote a letter, put it in a bottle, throw it in the coast of England, and several months later it shows up in coast of Miami, and they can read it or something like that. So that is what is called the circulation in the ocean. So it's called ocean conveyor belt. Ocean moves because of the temperature gradient. At some places, water will sink and then go under the ocean. Some places it rises and go over the surface. So those who have seen the movie, English movie, Finding Nemo, so there also they talk about the Great Australian Current. That is part of this conveyor belt. So the water will go around across the globe because of this temperature gradient. It triggers a circulation. So that circulation will take temperature from the equator side to the polar side. So the Great Australian Current, if you see in that Finding Nemo, is part of this conveyor belt. Just might I thought might be interesting for the students. Back to you, Shajil sir. I think Abhilash sir has connectivity issues.
Then the questions can be faced by Ravi Verma sir and Mohsin sir. Student will ask some questions, and Bharat, the student fellow of or your space will ask the questions, sir.
We can only attempt. I can say that I'm not an expert in the field.
Okay. We know the limitation, but if it is possible, we can make it a discussion. That's the only thing we want, sir. We don't want a final and ultimate one, sir. We are creating an environment only, sir. Thank you.
Yes, no problem.
Hello.
Yes, Bharat, go ahead.
Good evening, everybody. Once again, good evening. Let's move into the Q&A session. As of now, there hasn't been a lot of questions from students till now, but anyway, let's move to the questions. The first question is from Abhiram TP. Before I ask it, there are some things to be told regarding it. He has asked two questions. Now I'm going to comment on the second question. It's obvious that even though we are discussing of all these big problems going on about climate change, and that even though there are all these sorts of anomalies going around, we always believe that humans will always come up with a solution to the problems. And he's told something really interesting. So I'll start with the second question from Abhiram. So here, this is how it goes. I think it was meant to be asked to Abhilash sir, but anyway, let me ask. I think it would be better if I invite Abhiram to ask the question. Abhiram, can you please tell it?
Okay. First of all, thanks for Abhilash sir for your presentation. Bharatata, second question ആണോ?
അതെ അഭിരാം, second question വെച്ച് തുടങ്ങിക്കോ.
Okay. My question is this: how did the acidity of water affect in the marine plants? Can you describe more about it?
I think I meant the other question, but anyway, let's go with it.
I think you mean third question next.
Oh, I didn't know that you asked three questions, but anyway, let's start with the question you like most.
Yeah, okay. Then I start with my third question.
Abhilash sir is back, so you can ask him directly.
Okay.
And
Thank you, Abhilash sir, for your presentation.
mobile
And my
net connection എന്തോ പ്രശ്നമുണ്ട്. ചിലപ്പോൾ ഡിസ്കണക്ട് ആയി എളുപ്പം പറഞ്ഞു.
സർ നമുക്ക് ഈ ഫ്ലോട്ടിംഗ് ലാൻഡ് ഉണ്ടാക്കാൻ പറ്റുമോ? മീൻസ് ഇപ്പോ ബിസിനസിന്റെ അടിസ്ഥാനത്തിലൊക്കെ കുറച്ച് ഫ്ലോട്ടിംഗ് ലാൻഡ്സ് ഒക്കെ വന്നിട്ടുണ്ട്. നമ്മൾ ഈ ഫീൽഡ് റൈസിങ്ങിനെ ഓവർകം ചെയ്യാൻ വേണ്ടി അങ്ങനെ ഫ്ലോട്ടിംഗ് ലാൻഡ്സ് ഉണ്ടാക്കാൻ പറ്റും. മീൻസ് ഒരുപാട് ആൾക്കാരെ നമുക്ക് താമസിപ്പിക്കാൻ പറ്റുന്ന ഫ്ലോട്ടിംഗ് ലാൻഡ്സ്.
അത് മീൻസ് ഉണ്ടാക്കാൻ പറ്റും. ഇപ്പൊ നെതർലൻഡ്സിലെ ഒക്കെ ആ ഒരു മാതൃക കേട്ടിട്ടായിരിക്കും ചോദിച്ചത് അല്ലേ? അതാണോ?
സർ.
അപ്പം കാരണം ഓരോ റീജിയനും അതിൻ്റെതായിട്ടുള്ള, ഇപ്പം നെതർലാൻഡ്സിലെ സിറ്റുവേഷൻ അല്ല കേരളത്തിലെ, ഇപ്പം സിംഗപ്പൂരിലെ സിറ്റുവേഷൻ ആയിരിക്കില്ല കേരളത്തിൽ. അപ്പം കേരളത്തിലെ സിറ്റുവേഷൻ എന്ന് പറഞ്ഞാൽ നമ്മുടെ ഫ്ലോട്ടിംഗ് ലാൻഡ് ഉണ്ടാക്കേണ്ട ഒരു നെതർലൻഡ്സിന്റെ സാഹചര്യം എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഈ സീ ലെവലിന് താഴെയുള്ള പ്രദേശമാണ് നെതർലൻഡ്സ്. അതുപോലത്തെ നമുക്ക് ഈക്വലന്റ് ആയിട്ടുള്ള കേരളത്തിലെ പ്രദേശമാണ് കുട്ടനാടാണ്. അപ്പൊ കുട്ടനാടിന് ജനറ്റിക്കലി അതായത് നമ്മൾ ട്രഡീഷണലി കുട്ടനാടിന് അറിയാം, they are cultivating rice and everything below sea level, even in salt water. So that means either they are already adapted to that situation, live in that situation. The thing is that now after the 2018 flood, Uttanad also is being under the Rebuild Kerala initiative. There are a lot of houses as being നമ്മുടെ പുതിയ വീടുകളൊക്കെ വലിയ തൂണുകളിലൊക്കെ പണിഞ്ഞിട്ടുണ്ട്. പക്ഷെ ഒരു ബിഗർ ഫോമില് നെതർലാൻഡ്സിലൊക്കെ ചെയ്യുന്ന പോലുള്ള ഒരു സംഭവം ഇവിടെ പ്രാക്ടിക്കബിൾ ആണോ എന്ന് തീർത്ത് പറയാൻ പറ്റില്ല. കാരണം നെതർലാൻഡ്സിലെ അത്ര ടെക്നോളജിയും പിന്നെ അതുപോലുള്ള അവിടെ ഇപ്പം കേരളത്തെ സംബന്ധിച്ച് കഴിഞ്ഞാൽ ഈ ബിലോ സീ ലെവൽ ലാൻഡ് സർഫസ് എന്ന് പറയുന്നത് വളരെ കുറവാണ് കമ്പയർഡ് ടു ഓൾ ഏരിയ. അപ്പം നെതർലാൻഡ്സിന്റെ വേറൊരു റെസ്പെക്റ്റിൽ വേറൊരു ഫീച്ചറാണ്. കാരണം നെതർലാൻഡ്സിൽ ഈ പറയുന്ന പോലെ ഫ്ലഡിങ് സ്ട്രക്ചർ തന്നെ, അതായത് ക്ലൈമറ്റ് സ്ട്രക്ചർ തന്നെ വ്യത്യാസമാണ്. കേരളത്തിൽ ഫ്രീക്വന്റ് ആയിട്ട് ഉണ്ടാകുന്ന ഒരു സംഭവമാണ്. ഓരോ ലാൻഡ് ഫോംസിനും അനുയോജ്യമായിട്ട് നമുക്ക് പണ്ട് തൊട്ടേ നമുക്ക് അതിനോട് അഡാപ്റ്റ് ചെയ്ത് ജീവിക്കുന്ന ഒരു രീതി നമുക്കുണ്ടായിരുന്നു. പക്ഷെ അതെല്ലാം മാറി. അതോടൊപ്പം തന്നെ ഈ പറയുന്ന പോലെ ഈ കുട്ടനാടായാലും ഇത് വെറ്റ്ലാൻഡ്സിന്റെ അല്ലെങ്കിൽ പാടി ലാൻഡ്സിന്റെ ഒക്കെ ഏരിയ, അതായത് 85 സ്ക്വയർ കിലോമീറ്റർ അല്ലെങ്കിൽ ഉള്ളത് ഇപ്പം 2 lakhs താഴെയായിട്ട് മാറി. അപ്പൊ ഇത്രയും വെള്ളത്തിനെ അക്കോമഡേറ്റ് ചെയ്യാനുള്ള സ്പേസ് നമുക്ക് ഇല്ലാതായി. അതൊരു ഫാക്ടറാണ്. അതുകൊണ്ടാണ് ഈ പറയുന്ന പ്രശ്നങ്ങളൊക്കെ ഉണ്ടാകുന്നത്. അപ്പം ഇത് അത് മാത്രമല്ല ഒരു സൊല്യൂഷൻ എന്ന് അങ്ങനെ ഞാൻ വിചാരിക്കുന്നില്ല. കാരണം ഓരോ റീജിയനും അനുയോജ്യമായിട്ടുള്ള സൊല്യൂഷനാണ് നമുക്ക് ഉണ്ടാക്കേണ്ടത്. അതും നേച്ചർ ബേസ്ഡ് സൊല്യൂഷൻ ആണ്. ദാറ്റ് ഓൺലി വിൽ ബി സസ്റ്റൈനിങ്. അതായത് നമ്മൾ നേച്ചറിനെ മാറ്റി നിർത്തിക്കൊണ്ടുള്ള ഒരു സൊല്യൂഷൻ ഉണ്ടാക്കിയാൽ ഏതെങ്കിലും ഒരു കാലത്ത് ഇതുപോലുള്ള വേറെ എന്തെങ്കിലും കലാമിറ്റീസ് വരാം. അപ്പൊ നേച്ചർ ബേസ്ഡ് സൊല്യൂഷൻ ആണ് ഫോർ എ സസ്റ്റൈനബിൾ ഫ്യൂച്ചർ. ഇറ്റ് ഈസ് ബെറ്റർ.
Okay, sir. Can I ask my second question?
Yeah.
How did the acidity of water affect in the marine plants? Can you describe more about that?
Yeah, if you consider ocean, the pH value of ocean water is being reduced. That means ocean is becoming more and more acidic nature. So that will have a lot of impact on the ecosystem of the ocean. Mostly it will be affected on the coral ecosystem, because the coral ecosystem is like a forest ecosystem on the land, because around this coral ecosystem lot of small fishes, small planktons, zooplanktons, everything lives around this coral ecosystem. So that means when ocean water will become more acidic, this corals will be bleached out, so that that ecosystem disturbed. That will entirely affect the entire food web of the ocean. So that it will not only affect the chemistry of the ocean, but this changes will affect the biology of the ocean, and in turn the entire ecosystem. Sometimes ocean is generally considered as the total ocean. If you consider, it is generally considered as a sink for carbon dioxide. Maybe due to this warming of ocean, along with acidification, all will further increase in future. If all together will contribute more and more positive feedback, so that some point of time ocean cannot take more, and as Revama was telling, initially the ocean surface will warm, then this warmness will transfer to the total depth of the ocean. After that, ocean cannot take much heat from the atmosphere. So that means there will be a limit. So that this acidification also in turn affected by this, and all this is connected. So this is what the link of global warming with the ocean acidification, and the solubility and all depend on the temperature of the water. So that is also in a way all are connected.
Sir, one more question. How does the intense cyclones become indicators of climate change?
Yeah, Mohsin was telling about this water means holding capacity of the atmosphere. If temperature increase means more and more water can be hold. More and more water when it condenses, more per gram of water, lakhs of heat is being lakhs of joules heat is being liberated. So that means if more and more water condenses, more and more heat is being liberated. This it is like a heat engine. Gayormo sir was telling about the tropical polar heat regulation mechanism, is kind of heat engine. This atmosphere is warming. Ocean along with ocean warming means evaporation increases. Evaporation increases means atmospheric water vapor content increases. Atmospheric temperature increases means atmosphere can hold more and more water vapor. So that means atmosphere can hold more and more water vapor. At the same time, ocean can supply more and more water vapor to the atmosphere. So the again this positive feedback loop will work together to form more and more, liberate more and more heat in the atmosphere when it condenses. So that in turn will act as a positive feedback. So this is the general like a Carnot engine type of mechanism in the tropical cyclogenesis. More and more heat is being liberated. More, the intensity of the cyclone will get more and more. It's like intensity of the cyclone is also being increased. That is the link between climate change. The cyclone number may not change, but small system like I have been seeing earlier period we are witnessing many depression type of systems. But now the climate change is adding fuel to it, and it is whatever depression is happening earlier time, it is becoming nowadays cyclones and super cyclones like that. So that is the link. It is a indirect means indication of our changing climate.
Okay, thank you, sir. Thank you so much. That's all.
Thank you, Abhiram. Next, we have Adidev with a question. Adidev, can you please come forward and ask your question? Excuse me, Adidev, can you please come forward and ask your question?
Is muted. Adidev, mic unmute.
Hello, is it audible?
Yes, it is. Please continue, Adidev.
First of all, I thank for Abhilash sir for giving us a good class. And my question is that does Earth loses its atmosphere similar to Mars? If so, is it calculated in a D by H ratio? Hello?
I think Abhilash sir has left the meeting again. He has some technical glitches. Can anyone else comment on it? Panelists, sir, please.
I think we will wait for Abhilash sir to come back unless Mohsin sir want to comment on it.
Mohsin sir, can you comment on it?
Actually, I'm not familiar with this. Actually, what is happening now? What our Mars mission and all those things. It is we are adding to our knowledge regarding this. Actually, in the Mars, actually the atmosphere vanishes much earlier. So there we are studying how it is vanished this atmosphere and what happened earlier to what causes for the vanishing of that Mars atmosphere. Okay, so we are expecting it might have maybe it will happen in atmosphere itself, in our atmosphere also. That is my comment on this. I'm not expert on this.
Sir, isn't this phenomenon directly connected to things like solar flares and solar fields and all sorts of things and magnetic fields and things?
Solar flares actually a regular phenomenon in that in sun. Solar flares, and it's happening normally. So you might have heard about the that solar cycle. That means sunspot's number, depending on the sunspot number in the sun, we can in sometimes it happens that one cycle happens in 12 years. Okay, so and sometimes that sunspot will be high in number, and sometimes the sunspot will be in lower in number. Okay, so this will there are number of studies is going on regarding this, how the cyclone, that sunspots number or solar flares is affecting the Earth atmosphere as well as the Earth climate. Okay, so it is we cannot say regarding this. It will not give a positive feedback to the climate change as well as whatever we are discussing about that escaping of the atmosphere. I don't think I'm not sure that solar flares will contribute to what we are discussing now.
Oh, thank you, Mohsin sir. It's like I've heard before that solar winds and coronal mass ejections are one of the reasons why Mars and things like that on other planets actually lost their atmospheres, since Mars has.
Yeah, it might have. It might have influenced that one. Actually, we are having a magnetosphere. Earth is having a magnetosphere. That is actually acting as a shield to that CME and all those things. Okay, so that is actually a bigger protection from the solar flares. So that in Mars and other planets, I think it is not there.
Thank you, Mohsin sir. I think Abhilash sir is back. Adidev, can you please?
Yes.
Adidev, can you please repeat your question?
Okay, my bad, because today my net connection got some.
Hello.
Yeah. Repeat.
Abhilash sir, first of all, I thank you for this wonderful session. And my question is, does Earth loses its atmosphere similar to Mars? And if so, is it calculated in D/H ratio?
I don't have a definite answer to this particular question, because I think Devama sir and mostly is it is linked to the gravity and many factors like solar flares, how things are happening external to the planet. So, losing of atmosphere is nothing but entire collapse of gravity, right? Is it true? Because, yeah. So that point, I am not able to give a definite answer for that. Maybe Devu sir.
I think we have already discussed a little bit on that, so I think we can go to the next question.
Yeah.
That will be better.
Okay, sir.
Okay, thank you, sir.
Thank you, Adidev. Thank you, sir. Sir, there's a question from my side. I have heard in a lot of places, and there have been some reports and kind of things, that the intensity and the frequency of natural disasters like cyclones and hurricanes have increased in the past few years. I'm not sure if that is true. I've heard a lot of people speaking that way, but I've heard many a lot speaking in the other way, that there is no scientific reason or any scientific explanation for this argument that they are making. So is it true that in the past few years, the intensity or not the intensity, the frequency of such natural disasters, in particular cyclones and tornadoes, have been increasing, especially in concern to places like Florida and other places in the USA, where tornadoes and things are quite common? Is it true that the frequency has increased in such places?
Yeah. The general assumption is that frequency is being increased and intensity is also get affected by climate change. Both the cyclone, in terms of cyclone intensity, but in terms of frequency, we can say it's like that. Means like we can put it like this. The total, if you consider the world, the entire ocean basins where cyclones form, we can expect like 90 to 100 cyclones per year. That is a global number of cyclones per year. Average 90 to 100. So in which Western Pacific produces almost like 30, 35 typhoons. Their cyclones are known as typhoons. And followed by Atlantic and South Indian Ocean, then Indian Ocean and all. Indian Ocean altogether produce almost like 5 to 6 cyclones. Our contribution to this global average is like only 5 to 6%. So if you consider global number of cyclones, it is not exceeding. Like you already mentioned about Florida and the US. In 2005, US witnessed like 5 super hurricanes like Katrina, Wilma, Rita, Maria, Jones, like 5 super hurricanes in one season. That means that time lot of studies have come out like every year, next year, and every year this type of feature is coming up. So after that, in Atlantic, especially Florida and the east coast of west coast of US, didn't experience super hurricanes in 1 year. After that, that means the number is not increased. The cyclone can get interpreted. That is the thing we have. And also there is a lot of natural variability along with this anthropogenic changes. Like a natural common mode of short period oscillation is a kind of El Nino southern oscillation, which takes something like 2 to 5 years periodicity. So phases of this El Nino southern oscillation is also a factor which determines the year-to-year variability of the cyclones. That means all this together is happening along with this natural feature. Some certain phases of El Nino phase favors good number of cyclones in Atlantic. Certain phase of El Nino, the opposite La Nina or Enso phase, will suppress cyclones in some other part of the world. So that means all this natural variability along with the anthropogenic factors contributing to this. So the thing is that, as I said, the total number of cyclone is not exceeded about 100 any of the years, but it is remain between 85 and 100. There is a lot of intra-annual variability, year-to-year variability. This year maybe 85, next year maybe 95, again next year maybe 80. So this type of variability is already there. That is part of natural variability. But along with that natural variability is if climate change induced global warming adds to it, so that if everything comes in a favorable phase, the cyclones will can intensify very big super hurricanes like that. So that's why Arabian Sea witnessed last year super cyclones like Kyar and another same that if you look at the Pacific, you can find almost like 5 cyclones, 5 typhoons at a time. Simultaneously, you can see Pacific. If you look at Pacific cyclone numbers, one point of time you can see 3, 4, 5 cyclones, up to 5 cyclones, because the ocean basin is large. That type of feature is not means common in Arabian Sea. But last year we have seen that 2 cyclones existed side by side in Arabian Sea, like Kara and Maha. So this is a kind of changing pattern. So this we can expect like more and more system number over the globe may not change much, but more and more system will get the potential to become more intensified. I hope
Thank you, sir. Thank you, sir. Yes, we are not really in the safest of places. Next, I have another question from Adidev. I think I will narrate it rather. So he has asked it. We know that the continents today are formed from Pangea as the plates are moving. Is there a possibility that the continents can combine again and form a second Pangea? If so, when?
That is means now also plates are moving with a speed of like a few millimeter per year or something. So sometimes maybe I don't know the exact time when all this continent again come together form another big continent, floating continent. So that can also be possible at the scale it is, but it is very difficult to say uh, when it will happen. So it all depends on many other geological factors also.
Yes, sir. What seems from all this is that there is no point in having disputes over borders of countries like this, because obviously they are going to be one in the future.
Yeah,
Next, I have Sriram who wants to ask a question. Sriram, can you please come forward and ask your question? Sir, can you hear me?
yeah, good.
Good evening, sir. We are in a pandemic situation. Like we all know, we had some political issues on the initial stage of Corona. That is, the climate change may, or the hot climate will help the less spreading of the disease. Like that, I saw a article in World Health Organization site that based on this climate change and spreading of the diseases like AIDS, hepatitis C, hantavirus, malaria, something like that. I have a question: is that what is the significance or the how it causes the climate changes causes the spreading of the disease worsley?
Yeah, because climate has got some connection or link to the health in terms of transmitting the pathogens like virus or any vector-borne diseases. Transmission depends on the climate factor is a factor which determines the transmission of the either virus, bacteria, or any other pathogens. But am I audible?
Yes, sir, you are audible. Yes, sir.
Oh,
Yes, sir, you are audible, sir.
so that means, yeah. Like all these virus means airborne diseases like what you are telling, malaria, cholera, or any other forms of bacterial diseases and all. They can be transmitted to other region through air and water, and that is mostly linked to the climate. So that way, it has got means outbreak of many diseases has got a definite link to the um, climate. And also one thing also we have to look at in this sense that we don't know what are inside the polar region, like between the ice, the glaciers and all. So maybe some viruses or any kind of other type of bacteria or whatever, if that is trapped inside those ice core, I mean glaciers or um, ice. By global warming, this may also expose to by the time the Arctic ice is being reduced, the aerial, both aerial and mass of ice also reduced. So that also expose more and more land to the atmosphere, so that if something is trapped inside, that also maybe may can influence. So all this linked to climate only, means like a lot of link to the bacterial, either bacterial or virus diseases, climate change. But specific to coronavirus, we cannot say now, because even biology people also don't know the exact features of the corona yet, because maybe 2 months back, even WHO was also under the impression that this is not being transmitted through air, because it is not being considered as a airborne particle. Like if it is airborne visit, it can aerosol particles, so that it can easily go inside our respiratory system. And now understanding of the corona also changed that can be airborne. It can transmit it to air also. That's what regarding corona we cannot say, because we don't know everything about the coronavirus. We also don't know whether the same variant of virus which is being transmitted from the Wuhan, the same virus which in Kerala. That also we don't know. Transmitting, maybe it may not end up directly from Wuhan to Kerala. It might have gone to Europe, or from America to this Middle East. From that, there on only have been entered to our region. So all this while all this circulation, virus itself might have been mutated. So whatever virus which is originated in Wuhan might have already mutated in while it is reaching other part of the world. So this is another cause of globalization, because earlier, like swine flu, maybe 100, the swine flu also spreaded, but it was not spreaded like this fast. So that means the mobilization of human being also is affected by this spreading of this virus. And another best thing regarding this lockdown related to coronavirus is that our air is get more purified, and our carbon emission is reduced. All these are also because now we are kind of like a baseline or benchmark. Only we are doing only our essential things. Like, whatever required, we are not moving around to Mars. We are not using our vehicles much. So that this as for reference. Minimum activity. So I think all health related transmission is related to. I think I answer your question. Or
Sure, sir.
Okay.
That was a very good question from Sriram in concern with the present scenarios. I think the question from students are there are a few questions from Shivaraman sir. He has been a very active participant of the webinar. It would be bad if I read his question, so I invite Shivaraman sir to please ask his questions.
Hello, can you hear?
Yes, sir, you're audible.
Yes, sir. Yes, sir. Yes.
You're audible, no? Acha. Dr. Abhilash, your lecture is very good. I enjoyed it. And I rarely have seen a lecture on climate. Now, is it possible to estimate theoretically the changes in atmospheric temperature due to different sources, say like ocean currents, tectonic motion, greenhouse effect? And is it possible to predict climate change? Any idea?
yes, sir. Because with a lot of mathematical modeling, we can the natural factors we can precisely give to the models. And what way it is being done is that we run this model to future only with the natural forcings like plate tectonics, the volcanic activities. We know the time of volcanisms every time, so that we can prescribe those type of natural features like sunspots cycle, solar activities. All this can be prescribed well in a model. So that first we will learn only the precision, the eccentricity, everything we can specify well in a model. So first we run the model by including only the natural factors. We run for the future. Then by including all other anthropogenic activities, so that is known as future realizations. Like a future, what will happen? We emit carbon dioxide at this rate. Like there are a lot of socio-economic factors into it. So that we have like normally what interparliament of climate change is doing is that they devise few pathways because we don't know what will happen in the future. Regarding natural factors, we can fix or they are happening on a definite cycle. But in the future, anthropogenic factors can go and stabilize some point of time, and then sometimes it can reduce. Okay, so that means we run the model with few realizations, like a few pathways, like a few concentration pathways, like RCP, representative concentration pathways. It is known as representative concentration pathway. They impose this model with few type of pathways, like minimum pathway. Maybe by next year, if carbon dioxide or emission is reduced by 10% of the level of 1990s. Like that, there are different pathways we impose to the model along with the natural factors. So we will find out based on different pathways how much temperature would be after 2100 and after 2200. So this way we can estimate.
Thank you. Very good.
Yeah.
Another question is, does the Earth mutation any effect on the temperature of the atmosphere? Because we know that seasons are created because the Earth's axis is tilted. But the mutation effect, is it visible in the temperature variation?
Compared to the obliquity, the axial tilt, this effect will be considering the percentage of influence will be less than the obliquity or eccentricity effect. It will have a definite impact because the orientation of the axis is being distorted. So that will have minimum effect compared to the obliquity effect and the eccentricity.
Okay, thank you.
Mr. Varun, Mr. Varun,
Yes, sir.
questions are getting over or some more questions are there?
No, sir. That was the last question. We are going to conclude.
Okay.
Yes, sir. Yes, sir.
Okay. So can I take 2 minutes?
Yes, sir. Sure.
Before Kutisar entering, give me one half minute, sir. Okay, sir.
Okay. Please go ahead.
I want to introduce Kutisar to you. That's why. This is our Kutisar. He is no. I want to say to our Abhilash sir, I haven't said that. That's why. And a lot of people are there, and this is our Kutisar. He is in the soul of this UL Space Club. He started it 4 years back, and continuously we are conducting a lot of space camp like that. And the corona made us to do these things. We have the motivation with us, our guru, and he is the mentor of our UL Space Club, and he is continuously motivating. He was a former director of ISRO, and he worked at a lot of institutions all over India. That's I think a lot of TAFR is there, and lot of institutions he worked, and that's our Kutisar. That's I have to introduce you about him. Okay, thank you.
Thank you so much. It's a very humble attempt from our side, and that humbleness has grown big because of the contributions of our today's stalwarts. Dr. Abhilash, he came and gave a very good session. Our 9th session of the space webinar is made so good by Dr. Abhilash's presence. And Professor Ravi Verma has been very close to us, and we have known him for quite long, and his contribution is always there from the past as well. And today also his presence and his interactions and interventions have made it a very purposeful session. And Muhammad, who has come to us, a very young scientist with a lot of expectation in NIT, and I welcome all the three of you, and also thank for your excellent contributions in making this Space Club and the webinar sessions very lively and purposeful and helpful for our students. Now, before I close, I just wanted to say thanks to also not only our students and all other dignitaries who have come here. Of course, there is a formal thanks coming, but Dr. M.R. Shivaraman, who just came and spoke ask questions. He is going to be our next speaker, and his topic is GPS, Geopositioning System. He is my friend and colleague in Space Application Center, Ahmedabad. He retired from there and very active with a lot of student activities. The next Saturday, we will be having Dr. M.R. Shivaraman. I welcome him in advance now itself. So thank you very much for all those who are present and made this session great. So back to Shajil Marsh.
Okay, sir. Before that, I have to present one more our program had here for our audience. One second, I will present.
Okay, before Shajil sir presents, thank you everybody. The question answer session is over now. Shajil sir is going to tell you about the next activity of UL Space Club. Back to you, Shajil sir.
ക്വസ്റ്റ്യൻ ആൻസർ സെഷൻ തീരുന്നതിന് മുമ്പ് എനിക്കൊരു കുട്ടി ചോദ്യം ചോദിക്കാനുണ്ടായിരുന്നു. നിസ്സാരപ്പെട്ട ഒരു സംശയം. നമ്മള് പിന്നെ മഴ പെയ്യുമ്പോൾ ചിലപ്പം റോഡിന്റെ ഒരു സൈഡിൽ മഴ പെയ്യുന്നത് കാണാം, മറ്റേ സൈഡിൽ മഴ പെയ്യാതിരിക്കുന്നതും കാണാം. ആ ഒരു വിരോധാഭാസത്തിന്റെ കാരണം എന്തായിരിക്കും? അഭിലാഷ് സാറിനോടാണ് ചോദ്യം.
മഴയെന്ന് പറയുന്നത് ഒരു ഇപ്പോഴും കറക്റ്റ് ആയിട്ട് അതായത് ലോക്കൽ ഫീച്ചേഴ്സ് നമുക്ക് ഇതുവരെ അത് മനസ്സിലായിട്ടില്ല കറക്റ്റ് ആയിട്ട്. കാരണം ഈ ലോക്കലി ഉള്ള ഇപ്പൊ മൺസൂൺ ടൈം നമ്മളൊരു മഴയെന്ന് പറയുന്നത് കേരളം മുഴുവൻ ഒരേപോലെ പെയ്യുന്ന മഴയായിരിക്കും. അതേസമയം അതർ സീസൺ അതായത് മൺസൂൺ സീസൺ അല്ലാത്ത സമയത്ത് കിട്ടുന്ന മഴ ചിലപ്പം ആലുവയിൽ മഴ പെയ്യുമ്പോൾ എറണാകുളം ടൗണിൽ മഴ പെയ്യത്തില്ല. അതൊക്കെ ലോക്കലൈസ്ഡ് സിസ്റ്റം ആയിരിക്കും. അപ്പൊ അങ്ങനെ ഈ ക്ലൗഡിന് തന്നെ പല തരത്തിലുള്ള ഫീച്ചർ. ഇപ്പൊ ഒരു ക്ലൗഡ് ഡെവലപ്പ് ചെയ്ത് കഴിഞ്ഞാൽ അത് മഴ പെയ്യണമെന്നില്ല. അത് അവിടെ വെച്ച് തന്നെ ഇവോപ്പറേറ്റ് ചെയ്തു പോകും ചില ക്ലൗഡ്സ്. അതുപോലെ തന്നെ ഇത്തരം ഈ ചില ഈ റോഡെന്ന് പറയുന്നത് ഒരു ഡെഫിനിറ്റ് ബൗണ്ടറി ഒന്നുമല്ല. റോഡൊരു ബൗണ്ടറി ആയിട്ടൊന്നും അഫക്ട് ചെയ്യുവാണെന്ന് എനിക്ക് തോന്നുന്നില്ല. കാരണം ഒരു ഹൈവേയുടെ ഒരു സൈഡ് മഴയും അടുത്ത സൈഡ് മഴയില്ല എന്നൊന്നും നമുക്ക് പറയാൻ പറ്റത്തില്ല. അപ്പൊ നമ്മുടെ ഒരു ഹൈവേ കൂടെ വണ്ടി ഓടിച്ച് പോവുകയാണെങ്കിൽ നമ്മൾ പോകുന്ന ഡയറക്ഷനിൽ മഴ പെയ്യുന്നുണ്ടെങ്കിൽ അത് രണ്ട് സൈഡിൽ മഴ പെയ്യുന്നതാണ് എന്റെ ഒരു വിശ്വാസം കണ്ടിട്ടുള്ളത്. ഒരു സൈഡ് ഇപ്പുറത്ത് അപ്പം റോഡിന്റെ ഓറിയന്റേഷൻ. പക്ഷെ ഇപ്പം നമ്മളിപ്പം വയനാട്ടിൽ കൂടെ പോവാണെങ്കിൽ മലയുടെ ഓറിയന്റേഷൻ അതായത് ജോഗ്രാഫിക് കോണ്ടൂറിന്റെ ഓറിയന്റേഷൻ അനുസരിച്ച് ചിലപ്പോൾ മഴ പെയ്യാം റോഡിന്റെ അപ്പുറത്തെ സൈഡ് ഇപ്പുറത്തെ സൈഡ്.
ഞാൻ റോഡെന്ന് ഉദ്ദേശിച്ചത് നമ്മൾ തമാശയായിട്ട് എപ്പോഴും പറയലുണ്ട് പഞ്ചായത്ത് അടിസ്ഥാനത്തിലാണ് മഴ പെയ്യുന്നത്, വെസ്റ്റ് ക്യാമ്പസിൽ മഴയില്ല എന്നൊക്കെ തമാശയാക്കലുണ്ട്. അപ്പൊ ഈ ഒരു വ്യത്യാസം ഒരേ ഏരിയയിൽ തന്നെ പലപ്പോഴും കാണുന്നത് എന്തുകൊണ്ടാണ്? സാറ് പറഞ്ഞതുപോലെ ആലുവയിലും കോഴിക്കോടും എന്നുള്ള വ്യത്യാസം മനസ്സിലാക്കാം. പക്ഷെ ഒരേ ഏരിയയിൽ തന്നെ ചിലയിടത്തുണ്ട് ചിലയിടത്തില്ല. ആ ഒരു സംഭവത്തിന്
അത് ഈ ക്ലൗഡിന്റെ സിസ്റ്റം ക്ലൗഡ് ഉണ്ടാകുന്നത് പല സ്കെയിലാണ്. ഞാൻ മുമ്പ് സൂചിപ്പിച്ചു ആലുവയിലും കോഴിക്കോടും ഒരേപോലെ മഴ കിട്ടുന്ന ക്ലൗഡ് എന്ന് പറഞ്ഞാൽ സെയിം ക്ലൗഡ് സിസ്റ്റം ആയിരിക്കും. ഈ ക്ലൗഡിന്റെ ഒരു ഏരിയൽ എക്സ്റ്റെൻഡ് എന്ന് പറഞ്ഞാൽ അതിനെ പല സ്കെയിലിൽ ക്ലൗഡ് തന്നെ ഉണ്ടാകുന്നത് ഓർഗനൈസേഷൻ ചെയ്യുന്നത് തന്നെ ഒരു 1 കിലോമീറ്റർ വിഡ്ത്തുള്ള ക്ലൗഡ് മുതൽ 20 കിലോമീറ്റർ വിഡ്ത്തുള്ള ക്ലൗഡ് ഉണ്ടാകും. അതുപോലെ തന്നെ ഈ ക്ലൗഡ് കുറേയധികം ക്ലൗഡ് ക്ലസ്റ്റേഴ്സ് ചെയ്യുന്ന ഒരു ഓർഗനൈസേഷൻ അതായത് മീസോ സ്കെയിലായിട്ട് ഓർഗനൈസ് ചെയ്യുന്ന ക്ലൗഡ്സ് ഉണ്ടാകാം. അപ്പൊ അങ്ങനെ മീസോ സ്കെയിലായിട്ട് ഒരേപോലെ എല്ലാ സ്ഥലത്തും മഴ പെയ്യുമ്പോൾ ആ ഒരു ക്ലൗഡിൽ നിന്നാണ് നമുക്ക് മഴ പെയ്യുന്നതെന്ന് പറയാൻ പറ്റില്ല. കാരണം അതിപ്പോ മൺസൂൺ ടൈമിൽ നമ്മൾ എടുത്തു കഴിഞ്ഞാൽ കോഴിക്കോടും എറണാകുളത്തും ഒരേപോലെ മഴ കിട്ടും. പക്ഷെ അത് രണ്ടിടത്തും രണ്ട് ക്ലൗഡിൽ നിന്നായിരിക്കും മഴ കിട്ടുന്നത്. പക്ഷെ അതിപ്പോ അത്തരം ക്ലൗഡിന്റെ ഓർഗനൈസേഷൻ ആണ് അതിന്റെ വലിയൊരു സിസ്റ്റമാക്കി മാറ്റുന്നത്. അതേസമയം നമ്മൾ പ്രീ മൺസൂൺ അതായത് ഇടവപ്പാതിയിലുള്ള മഴയുടെ സ്ട്രക്ചർ അല്ല തുലാവർഷത്തിലുണ്ടാകുന്നത്. തുലാവർഷത്തിലാണ് ഇങ്ങനത്തെ ഈ പറഞ്ഞ ലോക്കലൈസ്ഡ് മഴ കിട്ടുന്നത്. അതിന്റെ സ്കെയിൽ എന്ന് പറയുന്നത് ഏകദേശം 2 കിലോമീറ്റർ അല്ലെങ്കിൽ 3 കിലോമീറ്റർ ആയിരിക്കും. അത് ഇന്ന സ്ഥലത്ത് ഉണ്ടായിക്കൊണ്ടാന്നില്ല. ഒരു സ്ഥലത്ത് 3 കിലോമീറ്റർ ഉള്ള ഒരു ക്ലൗഡ് സ്ട്രക്ചർ ഉണ്ടാകും, അതിന്റെ വലിയ മഴ കിട്ടുന്നില്ല. അപ്പം ഓരോ ഈ ക്ലൗഡിന്റെ ഫീച്ചേഴ്സും അതിന്റെ സ്ട്രക്ചറും എല്ലാം സീസണലി ഡിപ്പെൻഡന്റ് ആണ്. അതിൽ ലോക്കലായിട്ടുള്ള എഫക്റ്റോടൊപ്പം തന്നെ ഈ പറയുന്ന പോലെ സീസണൽ എഫക്റ്റും വളരെ വലുതാണ്. അപ്പം അതാണ് ഓരോ ഇപ്പൊ നമ്മളിപ്പം കേരളത്തിലും മീൻസ് കൊച്ചിയിലും കോഴിക്കോടും ഒരേപോലെ ഒരു ദിവസം മഴ പെയ്തെന്ന് പറഞ്ഞാൽ രണ്ടും ഒരു ക്ലൗഡിൽ നിന്ന് പെയ്ത മഴയെന്നല്ല പറയാൻ പറ്റും. ഡിഫറെന്റ് ക്ലൗഡ് ആയിരിക്കും. അപ്പൊ ഇങ്ങനത്തെ കുറെ ക്ലൗഡുകൾ ഓർഗനൈസ് ചെയ്യുന്നതായിരിക്കും ആ ഒരു ദിവസം രണ്ടിടത്ത് ഒരേ മഴ കിട്ടും. ആ സമയം ചില ദിവസം ഈ ചെറിയ ക്ലൗഡ് ഉണ്ടാവും, 2 കിലോമീറ്റർ അല്ലെങ്കിൽ 3 കിലോമീറ്റർ ഡയമീറ്ററുള്ള ക്ലൗഡ് ഉണ്ടാവും, അതിന്റെ വെളിയിൽ മഴ കിട്ടും. അപ്പൊ ഇങ്ങനെ ക്ലൗഡിന്റെ ഓർഗനൈസേഷൻ തന്നെ ഒരു വലിയ ബിഗ് സയൻസ് ആണ്. അത് ഇന്നേ വരെ അതിന്റെ ഫുൾ, കാരണം ഇതിന്റെ ഒബ്സർവേഷൻ ഇല്ല. ഇത് ആകെ നമുക്ക് ക്ലൗഡിനെ കുറിച്ചുള്ള ഒബ്സർവേഷൻ ഉള്ളത് സാറ്റലൈറ്റ് ബേസ്ഡ് ആണ്. സാറ്റലൈറ്റ് ബേസ്ഡ് അറിയാമല്ലോ. സാറ്റലൈറ്റ് ബേസ്ഡ് ആണെങ്കിൽ പുറത്തു നമ്മുടെ ഭൂമിയുടെ പുറത്തുനിന്ന് പോകുന്ന എനർജി മാത്രമേ അത് ഡിറ്റക്ട് ചെയ്തുള്ളൂ. എന്നിട്ട് വേറെ പല തരത്തിലുള്ള ഇൻവേഴ്സ് മോഡലിംഗൊക്കെയാണ് അതിന്റെ നമ്മള് ക്ലൗഡിനെ പറ്റി സ്റ്റഡി ചെയ്യുന്നത്. അപ്പൊ ഇപ്പം നമുക്ക് കൂടുതൽ ഈ എയർക്രാഫ്റ്റ് വെച്ചിട്ടുള്ള ക്ലൗഡ് ഒബ്സർവേഷനും ഈ റഡാർ വെച്ചിട്ടുള്ള ഒബ്സർവേഷനും ഒക്കെ നമുക്ക് കിട്ടുന്നുണ്ട്. അതുവഴി മേ ബി ഫ്യൂച്ചറിൽ നമുക്ക് ഇതിന്റെ ഫുൾ മൈക്രോ ഫിസിക്സ് എന്താണെന്ന് നമുക്ക് മനസ്സിലാവും. അപ്പം കൂടുതൽ ക്ലൗഡിനെ പറ്റി നമ്മൾ കൂടുതൽ സ്റ്റഡി ചെയ്യേണ്ട ഒരു ഏരിയയാണ്. ലിമിറ്റേഷൻ ഇതിന് ഒബ്സർവേഷൻ ഇല്ലാതെ റഡാർ തന്നെ കൊച്ചിയിൽ ഒരു റഡാർ ഉണ്ട്. അതോടൊപ്പം തന്നെ വേറെ ഒത്തിരി ക്ലൗഡ് റിലേറ്റഡ് ഒബ്സർവേഷൻ ക്ലൗഡിന്റെ ഡ്രോപ്പിന്റെ സൈസിലുള്ള അത് 2 മില്ലിമീറ്റർ തൊട്ട് 1 സെന്റിമീറ്റർ വരെ 100 മില്ലിമീറ്റർ വരെ ഉള്ള ക്ലൗഡിന്റെ സൈസ് ഉണ്ട്. ഓരോ ക്ലൗഡിന്റെ റെയിൻ ഡ്രോപ്സിന്റെ സൈസ് വ്യത്യാസമാണ്, അതിന്റെ റേഡിയേറ്റീവ് പ്രോപ്പർട്ടീസ് വ്യത്യാസമാകും. ഓരോ ഇതിനെപ്പറ്റി എന്താ പറയുക, എസൻസ് ആയിട്ട് പറയുകയാണെങ്കിൽ ക്ലൗഡിന്റെ ഓർഗനൈസേഷൻ ആണ് ഇതിൽ പ്രധാനം. 2 കിലോമീറ്റർ വ്യാസമുള്ള ക്ലൗഡ് തൊട്ട് 200 കിലോമീറ്റർ വ്യാസമുള്ള ക്ലൗഡ് ക്ലസ്റ്റേഴ്സ് വരെ ഉണ്ടാകും. അപ്പൊ ഇത് അതുകൊണ്ടാണ് മൺസൂൺ ടൈമിൽ ഉണ്ടാകുന്ന ക്ലൗഡ് ക്ലസ്റ്റേഴ്സ് ആണ്. പക്ഷെ എല്ലാ വർഷത്തിലും ഉണ്ടാകുന്ന ഈ ലോക്കലൈസ്ഡ് ക്ലൗഡ്സ് ആണ്. അപ്പൊ അതുകൊണ്ടാണ് ഒരു സ്ഥലത്ത് മഴ പെയ്യുമ്പോൾ മറ്റു സ്ഥലത്ത്
Thank you, Abhilash sir. I think Shajil sir has to begin again. Shajil sir, is it fine? Hello, Shajil sir.
Shajil sir.
എന്റെ മൈക്ക് മ്യൂട്ടായിരുന്നു, അതുകൊണ്ടാണ്. സോറി. അപ്പോ വൺ മോർ ഞാനൊന്ന് ഷെയർ ചെയ്യട്ടെ. അപ്പൊ നമ്മുടെ 10ാമത്തെ പ്രോഗ്രാം വെബിനാർ സീരീസ് വരുന്നത് മോൺഡേ ആണ്. അത് നമ്മുടെ 59ാമത്തെ മോൺഡേ സെലിബ്രേഷൻ ആണ്. കഴിഞ്ഞ 4 വർഷമായിട്ട് നമ്മൾ നിരന്തരമായിട്ട് യൂണിവേഴ്സിറ്റികളിലും സർക്കാരിലും എല്ലാം വെച്ച് നടത്തിക്കൊണ്ടിരിക്കുന്ന ഈ പ്രോഗ്രാം ഇത്തവണ കൊറോണ വന്ന സമയത്ത് എന്ത് ചെയ്യുമെന്ന സമയത്ത് കുട്ടി സാർ പ്രപ്പോസ് ചെയ്തിരിക്കുന്നത് ദ മൂൺ ഡേ വിത്ത് ദ മൂൺ മാൻ എന്നാണ് ഈ പ്രോഗ്രാം വെച്ചിട്ടുള്ളത്. ഇന്ത്യയുടെ മൂൺ മിഷൻ ഡയറക്ടർ ആയിരുന്ന ഡോക്ടർ പത്മശ്രീ ഡോക്ടർ എം അണ്ണാദുരൈ അദ്ദേഹം നമുക്ക് വേണ്ടിയിട്ട് ഒരു വെബിനാർ സീരീസിൽ വരാൻ വേണ്ടി സമ്മതം തന്നിട്ടുണ്ട്. അദ്ദേഹം വരുന്നുണ്ട് 21ാം തീയതി. അദ്ദേഹത്തോടൊപ്പമുള്ള പ്രോഗ്രാമിൽ ഇത് നമുക്ക് മാതൃഭൂമിയുടെ ചിൽഡ്രൻ പബ്ലിക്കേഷൻ കൂടി ഈ പ്രോഗ്രാമിൽ നമ്മളോടൊപ്പം കോപ്പറേറ്റ് ചെയ്യുന്നുണ്ട്. അപ്പൊ അതിനകത്ത് ഒരു ഫേസ്ബുക്ക് ലൈവിനകത്ത് ഇപ്പൊ തന്നെ നമുക്ക് യൂട്യൂബില് നമ്മുടെ ഈ പ്രോഗ്രാം പോയിക്കൊണ്ടിരിക്കുകയാണ്. അപ്പൊ അതുകൊണ്ട് തന്നെ ഇതിനകത്തേക്ക് നമുക്ക് ലിമിറ്റഡ് ആയിട്ടുള്ള എൻട്രി ഗൂഗിൾ മീറ്റ് കൊടുത്തുകൊണ്ട് ബാക്കി ഫേസ്ബുക്ക് ലൈവും യൂട്യൂബിനകത്തും ലൈവ് സ്ട്രീമിംഗ് പോയിക്കൊണ്ടിരിക്കുകയാണ്. അപ്പൊ വെൽക്കം സ്പീച്ച് സന്തോഷ് പള്ളിക്കോട്, ചീഫ് സബ് എഡിറ്റർ മാതൃഭൂമി. നെക്സ്റ്റ് നമ്മുടെ വാട്ട് യുവർ സ്പേസ് ക്ലബ് ഈസ് എന്ന് പറയുന്നത് എന്താണ് നടന്നുകൊണ്ടിരിക്കുന്നത് പറയാം. നമ്മുടെ പ്രൊഡക്റ്റ്, ഞങ്ങളുടെ അഭിമാനം, ഈ 5 വർഷമായിട്ട് നടന്നുകൊണ്ടിരിക്കുന്ന ഇത്തരം പരിപാടികളിലൂടെ കുട്ടികളെ എങ്ങനെയാവണം എന്നുള്ളതിന്റെ ഒരു റോൾ മോഡലായ കുട്ടികൾക്കുള്ള റോൾ മോഡൽ തന്നെയാണ് ഭരത്. ഭരതിനെ എല്ലാവരും പരിചയപ്പെട്ടു കഴിഞ്ഞു. ഇപ്പോൾ ഒരു +2 സ്റ്റുഡന്റ് ആണ്. ഭരതിനെയും നമ്മൾ ഒരുപാട് ഉയർന്ന തലങ്ങളിലേക്ക് എത്തുക, ഇപ്പൊ ഇവിടെ ഇരിക്കുന്ന ഭാരതന്മാരായിട്ടുള്ള സയന്റിസ്റ്റുകളൊപ്പം ഒക്കെ തന്നെ ഇരുത്തുക എന്നുള്ളൊരു ആഗ്രഹം ഞങ്ങൾക്കുണ്ട്. ഭരത് തീർച്ചയായിട്ടും അത് നടപ്പിലാക്കും. ഭരതിനോടൊപ്പം മറ്റൊരു കുട്ടി കൂടി NTS നാഷണൽ ടാലന്റ് സെർച്ച് എക്സാമിനേഷൻ കഴിഞ്ഞ വർഷം ക്വാളിഫൈ ചെയ്ത ദേശീയ തലത്തിൽ ശ്രദ്ധയാകർഷിച്ച കുട്ടിയാണ്. അത് ഞങ്ങൾക്ക് വളരെയധികം അഭിമാനമുണ്ട്. ഈ പരിപാടി അധ്യക്ഷത വഹിക്കുന്നത് ULCCS. ഈ പരിപാടി UL സ്പേസ് ക്ലബ്ബ് നമ്മുടെ കേരളത്തിന്റെ വലിയ, ഏഷ്യയിലെ തന്നെ വലിയ കോപ്പറേറ്റീവ് സൊസൈറ്റിയായ നിർമ്മാണ മേഖലയിലുള്ള ഊരാളുങ്കൽ ലേബർ കോൺട്രാക്ട് സൊസൈറ്റിയാണ്. അതിന്റെ കീഴിലുള്ള UL എഡ്യൂക്കേഷൻ ആണ് ഇതിനെ സപ്പോർട്ട് ചെയ്യുന്നത്. അതിന്റെ ചെയർമാനായിട്ടുള്ള ശ്രീ രമേശൻ പാലേരി സാറാണ് ഇതിനകത്ത് അധ്യക്ഷത വഹിക്കുന്നത്. ചീഫ് ഗസ്റ്റ് ആയിട്ട് വരുന്നത് കോഴിക്കോട് റീജിയണൽ സയൻസ് സെന്റർ ആൻഡ് പ്ലാനറ്റോറിയത്തിലെ ക്യൂറേറ്ററും ഇതൊരു റിസോഴ്സ് ഞങ്ങൾ പരിചയപ്പെട്ടതിൽ ഇത്രയും വലിയ റിസോഴ്സ് വാസ്റ്റ് റീഡിങ് എല്ലാ ഏരിയയുള്ള ഒരു 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 അതിജ്ഞാനി തന്നെയാണ് നമ്മുടെ ശ്രീ മാനുഷ് ബാബുജി സാർ. അദ്ദേഹമാണ് വരുന്നത്. പിന്നീട് നമ്മളോട് പത്മശ്രീ എം അണ്ണാദുരൈ സാർ ഇനാഗുറൽ ടോക്ക് നടത്തും. അദ്ദേഹത്തിന് 1 മണിക്കൂറോളം വരുന്ന ടോക്കാണ് നമ്മൾ പ്രതീക്ഷിക്കുന്നത്. അവിടെയും ഒരു എക്സ്പേർട്ട് പാനൽ ഉണ്ട്. ഇത് എമിനന്റ് പേഴ്സണാലിറ്റീസ്. വൺ ഈസ് ഡോക്ടർ ആർ നവൽഗുൺ, ഫോമർ ഡയറക്ടർ സ്പേസ് ആപ്ലിക്കേഷൻ സെന്റർ ISRO അഹമ്മദാബാദ്, ഡോക്ടർ ശ്രീകുമാർ, ഫോമർ ഡയറക്ടർ ഇന്ത്യൻ ഇൻസ്റ്റിറ്റ്യൂട്ട് ഓഫ് ആസ്ട്രോഫിസിക്സ് ബാംഗ്ലൂരു, ഡോക്ടർ S രംഗരാജൻ, ഫോമർ ഡയറക്ടർ മാസ്റ്റർ കൺട്രോൾ ഫെസിലിറ്റി ISRO ഹസൻ. ഇവരെല്ലാവരും നമ്മുടെ പരിപാടികളോട് ചേർന്ന് നിൽക്കുകയാണ്. ഇത് US സ്പേസ് മാത്രമല്ല, ഓൾ ഓവർ ഇന്ത്യ, ഓൾ ഓവർ കേരള, എവിടെ വേണമെങ്കിലും നമുക്ക് സ്ട്രീം ചെയ്യാവുന്ന ഒരു സാഹചര്യമാണ് ഈ പരിപാടിയുടെ നമ്മൾ ഒരുക്കുന്നത്. അതിപ്പോൾ തന്നെ കോഴിക്കോട് ജില്ലയിലുള്ള സ്കൂളുകളിലേക്ക് എല്ലാം തന്നെ ഇതിനുള്ള സന്ദേശങ്ങൾ പോയി കഴിഞ്ഞു. അത് മാത്രമല്ല, ഇത് തുടർന്ന് പിന്നീട് നമുക്ക് കുറച്ച് മത്സരങ്ങൾ കൂടി സെറ്റ് ചെയ്തിട്ടുണ്ട്. സ്പേസ് ക്വിസ് ഇതെല്ലാം ഡിസൈൻ ചെയ്തത് നമ്മുടെ വരുൺ, ഭരത്, അഭിനന്ദ് ഇങ്ങനെയുള്ള കുട്ടികളാണ്. നമ്മുടെ കുട്ടികളുടെ ഐഡിയാസിനെ നമ്മൾ എക്സിക്യൂട്ട് ചെയ്യുന്നതാണ്. ഇറ്റ് ഈസ് ദ ഹോൾ പ്രോഗ്രാം ഈസ് ഓൺ ബൈ അവർ സ്റ്റുഡൻസ്. അപ്പൊ ഇതിനകത്ത് അവരെ നർച്ചർ ചെയ്യുന്നതിനോടൊപ്പം തന്നെ അവർക്ക് ഒരു ഓർഗനൈസേഷൻ കപ്പാസിറ്റി, ലീഡർ കപ്പാസിറ്റി എല്ലാം ജനറേറ്റ് ചെയ്യുന്ന ഒരു എൻവയോൺമെന്റ് ആണ് നമ്മൾ ഈ പരിപാടിയിലൂടെ ഉദ്ദേശിക്കുന്നത് എന്നതാണ്. അപ്പൊ ഇതിന് ക്രിസ്ത്യൻ നമുക്ക് ലിങ്കോ ആക്റ്റീവ് ലിങ്ക് ഇതിനകത്ത് കൊടുക്കുന്നുണ്ട്. അതേപോലെ പെയിന്റിംഗ് ഉണ്ട്. അതിന് വേണ്ടിയിട്ട് വലിയൊരു വണ്ടർഫുൾ കോമ്പറ്റീഷൻ നമ്മൾ വെച്ചത് മൂൺ എക്സ്പ്ലോറേഷൻ എസ്കേർവേ ടു ദ കോസ്മോസ് എന്ന് പറയുന്ന വിഷയത്തിൽ ഒരു കുട്ടി 8 മിനിറ്റ് ഒരു പ്രസന്റേഷൻ ഷൂട്ട് ചെയ്തിട്ട് അയക്കുന്ന പ്രസന്റേഷൻ കോമ്പറ്റീഷൻ ആണ്. അതിനകത്തോടെ കുറച്ചുകൂടി പ്രതിഭകളെ നമുക്ക് കണ്ടെത്താനൊക്കെ കഴിയും, മാർക്ക് ചെയ്യാൻ കഴിയും എന്നുള്ള പ്രതീക്ഷ കൂടി ഇതിനോടൊപ്പം ഉണ്ട്. ഏതായാലും വലിയൊരു ശ്രമം കോവിഡ് കാലത്ത് നമ്മൾ മറ്റു കാലങ്ങളിൽ ഇല്ലാത്ത വിധം അതിനെ മറികടന്നുകൊണ്ട് നമ്മുടെ കുട്ടികൾക്ക് നല്ല ചിന്തകൾ ഉണ്ടാവാനും അവരെ മുന്നിലേക്ക് നയിക്കാനുള്ള ഒരു പരിശ്രമമാണ് നമ്മൾ നടത്തിക്കൊണ്ടിരിക്കുന്നത്. അതോടൊപ്പം തന്നെ ഓരോ തവണയും ഇവിടെ വെബിനാറിൽ പങ്കെടുക്കുന്ന നമ്മുടെ പ്രിയങ്കരായ ബഹുമാന്യരായ ആളുകളെ നമ്മുടെ UL ഫാമിലി വെബിനാർ ഫാമിലി ഗ്രൂപ്പിലേക്ക് ആഡ് ചെയ്തുകൊണ്ടിരിക്കുകയാണ്. അപ്പൊ ഞങ്ങൾക്ക് ചെറിയൊരു അഭ്യർത്ഥന രവികുമാർ സാറിനോടും അഭിലാഷ് സാറിനോടുള്ളത്, നമ്മുടെ ഉദ്ദേശം കുട്ടികളെ ഇത്തരത്തിൽ വളർത്തിയെടുക്കുക എന്നുള്ളതാണ്. അതിനുവേണ്ടി നമുക്ക് പറ്റിയ റിസോഴ്സസിനെ സജസ്റ്റ് ചെയ്തുകൊണ്ട് ഈ വോളണ്ടറി ആക്ടിവിറ്റി നമുക്ക് മുന്നോട്ട് കൊണ്ടുപോകാൻ നിങ്ങളുടെ ഭാഗത്തു നിന്ന് എല്ലാവിധ സഹകരണവും ഉണ്ടാവണം എന്നുള്ള ഒരു അഭ്യർത്ഥനയാണ് ഞങ്ങൾക്ക് ഉണ്ടാവുന്നത്. രവിവർമ്മ സാർ ഓൾറെഡി അത് ചെയ്തുകൊണ്ടിരിക്കുന്നുണ്ട്, അഭിലാഷ് സാർ നമ്മളോട് ചെയ്യുന്നുണ്ട്. ഏതായാലും അത്തരം കാര്യങ്ങൾ കൂടി ഒരു റിഫ്ലക്ഷൻ പറഞ്ഞുകൊണ്ട് രവിവർമ്മ സാർ അതിനൊരു മറുപടി തരുമെന്ന് ഞാൻ പ്രതീക്ഷിക്കുന്നു.
എല്ലാം ചെയ്യാം. ഞാൻ മാത്രമല്ല, ഞങ്ങള് പിന്നെ ഇൻസ്റ്റിറ്റ്യൂട്ടിലെ other eminent personalities are also there. Everyone will help.
സാറേ, സ്കൂളിലെ നമ്മുടെ ഗിഫ്റ്റഡ് എഡ്യൂക്കേഷൻ പ്രോഗ്രാമിന് വേണ്ടിയിട്ട് മിഷൻ കണ്ടക്റ്റിലെ പ്രൊഫസർ ബ്രൂസി സിലിയെ നേരിട്ട് സ്കൂളിൽ എത്തിച്ചു തന്നൊരു അനുഭവം എനിക്ക് തന്നെ ഉണ്ട്. അതെപ്പോഴും വർത്തിയായിട്ട് ഇരിക്കുന്നു. അതേപോലെ തന്നെ ഇവിടെ ഇരിക്കുന്ന നിസാം അടുത്തെയും ഈ പ്രോഗ്രാമിലേക്ക് എനിക്ക് പരിചയപ്പെടുത്തിയത് രവിവർമ്മ സാറാണ്. വളരെ സന്തോഷം ഇത് തുടരുന്നതിൽ. പിന്നെ ആന്റണി സാർ എറണാകുളത്ത് നിന്ന് ഇരിക്കുകയാണ്. നമുക്ക് 27-ന് കുട്ടി സാർ അതിൽ 27 പ്രോഗ്രാം ഒരു ഡിക്ലറേഷൻ കൂടി കുട്ടി സാറിന്റെ ഭാഗത്ത് നിന്ന് ഞാൻ പ്രതീക്ഷിക്കുന്നു. കുട്ടി സാർ.
ഷജിൽ മാഷ് 27th ഷജിൽ മാഷ് പറഞ്ഞ 27th പറ്റിയ ഓക്കെ ആഫ്റ്റർ 21st മൂൺ ഡേ സെലിബ്രേഷൻ നമ്മളുടെ അടുത്ത പ്രോഗ്രാം 25th സാറ്റർഡേ വെബിനാർ, അതിനെപ്പറ്റി ഞാൻ പറഞ്ഞു കഴിഞ്ഞു. അത് കഴിഞ്ഞിട്ട് നമ്മുടെ നെക്സ്റ്റ് പ്രോഗ്രാം ഓൺ 27 that is കലാം മെമ്മോറിയൽ ടോക്ക്. ഡോക്ടർ അബ്ദുൽ കലാം മെമ്മോറിയൽ ഡേ ആണ്, അന്ന് ആനിവേഴ്സറി ആണ്. ആ ടോക്ക് നടത്തുന്നത് അബ്ദുൽ കലാമിന്റെ വളരെ കാലം ക്ലോസ് കൊലീഗ് സഹപ്രവർത്തനായിരുന്ന PN സുബ്രഹ്മണ്യം എന്ന VSSCയിലെ ഒരു വളരെ സീനിയർ സയന്റിസ്റ്റായി വിരമിച്ച ആളാണ്. അദ്ദേഹത്തിന് കലാം മെമ്മോറിയൽ ട്രസ്റ്റ് ഉണ്ട്. ആ ട്രസ്റ്റിലെ 1-2 പേരും കൂടി സംസാരിക്കും. ഒരു പ്രോഗ്രാം ആയിട്ട് അദ്ദേഹത്തിന്റെ കലാം മെമ്മോറിയൽ ടോക്ക് ഞങ്ങൾ ഈ വിധത്തിൽ തന്നെ നടത്തുന്നതായിരിക്കും. 27th 3 PM ആണ് അതിന്റെ സമയം. അപ്പോൾ അങ്ങനെയുള്ള 2-3 പ്രോഗ്രാം നമ്മൾ ഒന്നിച്ച് കൊണ്ടുപോകാൻ ഇതിലെല്ലാവരും നിങ്ങളുടെ എല്ലാവരുടെയും സഹകരണങ്ങളും പാർട്ടിസിപ്പേഷനും കോൺട്രിബ്യൂഷൻ ഉണ്ടാവുമെന്ന് പ്രതീക്ഷിക്കുന്നു. താങ്ക് യു വെരി മച്ച് ഫോർ കമ്മിങ്. ഓൾറെഡി നമ്മൾ 2 മണിക്കൂർ 20 മിനിറ്റ് ഇരുന്ന് കഴിഞ്ഞു, യാതൊരു മുഷിച്ചില്ല. സോ നമ്മളുടെ പ്രോഗ്രാം കൺക്ലൂഡ് ചെയ്യാൻ ഞാൻ ഷജിൽ മാഷോട് അഭ്യർത്ഥിക്കുകയാണ്.
ഇതിൽ ഔപചാരികമായിട്ട് നന്ദി പറയാൻ വേണ്ടി UL എഡ്യൂക്കേഷന്റെ കോർഡിനേറ്ററായ ദാമോദർ സാറിനോട് അഭ്യർത്ഥിക്കുന്നു.
ഹലോ കേൾക്കാമോ? ഇന്ന് നമ്മുടെ ULCCS ഫൗണ്ടേഷന്റെ UL സ്പേസ് ക്ലബിന്റെ 9ാമത്തെ വെബിനാറാണ് കഴിഞ്ഞിരിക്കുന്നത്. കാലികമായിട്ടുള്ള വളരെ പ്രധാനപ്പെട്ട ഒരു വിഷയമാണെന്ന് ചർച്ച ചെയ്തിട്ടുള്ളത്. ഭൂമിയിൽ മനുഷ്യ ജീവൻ തന്നെ, എന്ത് മനുഷ്യനായാലും സസ്യങ്ങളായാലും എന്തിന്റെയും നിലനിൽപ്പ് ചോദ്യം ചെയ്യുന്ന ഒരു വിഷയം ക്ലൈമറ്റ് ചേഞ്ച്. അത് വളരെ നല്ല രീതിയിൽ അതിന്റെ എല്ലാ വശങ്ങളും ഇവിടെ ചർച്ച ചെയ്യുന്നുണ്ടായിട്ടുണ്ട്. ആ ചർച്ചയിൽ ഡോക്ടർ അഭിലാഷ് സാറ് വളരെ നല്ല രീതിയിലാണ് ഇതിവിടെ അവതരിപ്പിച്ചിട്ടുള്ളത്. സാറിന് ULCCS ഫൗണ്ടേഷന്റെ പേരിൽ ഹൃദയപൂർവ്വം നന്ദി രേഖപ്പെടുത്തുകയാണ്. അതോടൊപ്പം തന്നെ ഇതിൽ പാനൽ ലിസ്റ്റായിട്ട് വന്നിരിക്കുന്ന ഡോക്ടർ രവിവർമ്മ സാറുണ്ട്, അതുപോലെ തന്നെ ഡോക്ടർ മൊഹ്സിൻ സാറുണ്ട്. ഇവരെല്ലാം തന്നെ ഇതുമായി ബന്ധപ്പെട്ട ചോദ്യങ്ങൾക്ക് ഉത്തരം തരികയും അതുപോലെ അഭിപ്രായങ്ങൾ രേഖപ്പെടുത്തുന്ന സജഷൻസ് പറയുകയും ചെയ്തിട്ടുണ്ട്. അവർക്കും 2 പേർക്കും, രവിവർമ്മ സാറിനും മൊഹ്സിൻ സാറിനും ULCCS ഫൗണ്ടേഷന്റെ പേരിൽ നന്ദി രേഖപ്പെടുത്തുകയാണ്. അതുപോലെ ഈ യോഗത്തിൽ, ഈ വെബിനാറിൽ പങ്കെടുത്ത എല്ലാവർക്കും, പ്രശസ്തരായിട്ടുള്ള ശാസ്ത്രജ്ഞന്മാരൊക്കെ നേരത്തെ പങ്കെടുക്കുന്നവരുണ്ട്. അവർ ഒരു തവണ ഈ വെബിനാറിൽ സ്പീക്കേഴ്സ് ആയിട്ട് വന്നു കഴിഞ്ഞാൽ തന്നെ അടുത്ത വെബിനാറുകളിലെല്ലാം തന്നെ അവർ ശ്രോതാക്കളായി മാറുന്ന ഒരു സ്ഥിതിയാണുള്ളത്. അത് ഈ വെബിനാർ സീരീസിന്റെ പ്രാധാന്യം, അതിന്റെ ഒരു ഉള്ളടക്കം, ഇതിന്റെ പ്രാധാന്യം മനസ്സിലാക്കിക്കൊണ്ട് തന്നെയാണ് അവര് ഈ വെബിനാറുകളിൽ പങ്കെടുക്കുന്നത്. അവർക്കെല്ലാം തന്നെ ULCCS ഫൗണ്ടേഷന്റെ പേരിൽ നന്ദി രേഖപ്പെടുത്തുകയാണ്. ഈ വെബിനാർ അവതരിപ്പിച്ച പങ്കെടുത്ത എല്ലാവർക്കും ഒരിക്കൽ കൂടി നന്ദി രേഖപ്പെടുത്തിക്കൊണ്ട് ഞാൻ എന്റെ വാക്കുകൾ അവസാനിപ്പിക്കുന്നു. ഓക്കെ. ഓക്കെ.
Sir,